Hello, very good morning, students. Welcome to BYJU'S exam prep. Good morning, all of you. Very good morning. I hope everyone is good, fine. Good morning, students. Good morning. Okay. So today we're gonna have a quick revision of a very interesting, small and important subject, that is engineering mechanics, right? And it's very important because in engineering mechanics, it's more sort of like we'll be getting numerical oriented questions, right? So we'll be understanding the concept and logic in detail. Each and everything will be discussed so that you are not facing any difficulty during your examination, right? Good morning, Abhi. Good morning. How are you? Yes, very good morning. Okay. Please do confirm my audio and video all good. There is no problem. Yes, all perfect. Very good morning. Okay, all right. Hello, good morning. Hello, Harikesh. Hello, Shreyas. Good morning. All clear. Okay, fine. Thank you. All right. So, in engineering mechanics, if I say from the last 2-3 years of trend, they're asking you mainly questions from the friction. Like if I talk about mechanical students, they will be asking you question from the friction, or they'll be asking you question from your this one from the dynamics part, right? Mainly they are asking question from these two topics, right? If I talk about civil, normally you are getting questions from the equilibrium conditions, from friction part, more sort of question you are getting from those topics. Hello, hello, good morning. Very good morning, all of you. 1 second, let me check. Okay, perfect. Good morning. Let me check from my end. I think all good, right? Yes. Okay. I hope so. You have got mechanic students have got the PDF yesterday. I've already uploaded on my Telegram channel, and all of you have received that. Okay. Good morning, Akhil. Good morning. Very good morning. All right. So let's begin. करें शुरुआत. Let's start. है ना? Let's start our session and let's wind up. Mechanics will be covered in like 4 hours. Okay, 4.5 hours max to max. We'll be covering in one stretch without any break, and directly I'll be giving you lunch. We'll be covering before the lunch. Okay, fine. Chaliye. If I talk about myself, I hope so everyone has connected with me. I'll be sharing the PDF of this particular class on this Telegram channel, that is Mechanical by Suraj, that you are seeing on the screen. Okay, I'll be sharing the PDF on this particular Telegram channel. Expected weightage, you can get near about like 4-5 marks. Once they have asked for 7 marks, but I would say that 4-5 will be the expected weightage from the engineering mechanics for the gate examination, right? So definitely you can think in that direction, and you will be getting only the numerical oriented question. Theoretical is very less chances. Even they were asking, it will be very easy for 1 marks. Okay. Good morning, Lemon. Good morning, Faninder. Good morning, all of you. Okay, all right. So on 17th of January, Rakesh sir will be coming up live on our BYJU'S exam prep app for all the 2025 students. And very important update, I hope so everyone is taking up the quiz also. Those who are not yet attempting the quiz, because after every marathon session, you will be having the quiz also of that particular subject. Let us suppose yesterday you have studied industrial engineering. So you can attempt the quiz in our app. What you have to do is you can scan this code and you can directly link to our app, right? Or else what we can do is there is one link at the bottom of every class, right, where you can download or get to the quiz. Like there is a direct link for the quiz, and also there is a link. Let me hide myself. I hope so you are able to see now. There is a direct link from where you can have a one-on-one interaction with our counselor, which who will be helping you to clarify whatever doubt you are having for the gate examination. Okay, fine. So these two important update. This one. This is our link for the class. At the bottom of every class, you will be able to see. Let me hide myself also. And this is the link for the one-on-one counseling that you can avail. Along with that, there is the QR code that you can scan on the screen. Okay, आप class के बाद you can scan it and you can definitely get the benefit of this. So this is the complete playlist that you are able to see. Almost you have completed 80% of our mechanical subjects. You're left out with applied thermodynamics, heat transfer, material science, and the metal cutting. And after that, from 22nd of January, your mathematical and aptitude classes will be started. So I think you are also geared up for that also. Okay. Chaliye, good morning, very good morning. Achha, I think everyone is attempting the mock test for this full length mock test. I hope so everyone is attending this full length mock test because this is very important. This will be completed by 19th of January, right? This particular mock test, full length mock test will be over by 19th January. So make sure you, before 19th Jan, you are registering this particular test and you are attempting this both for civil and mechanical. Okay, it's a full length test which will be having the same pattern as of the gate examination. Okay, chaliye. So let's begin with the session, right? I hope so. All good, all perfect. Can we start? Okay, done. Chaliye. So let's begin with the session and let's hope that we'll be covering in 4 hours. Okay, by 2 o'clock we'll be able to wind up our session. Okay, chaliye, let's go. Now, first and foremost thing, what do you mean by this word engineering mechanics, or simply we can call it as mechanics? What is a mechanics? Now, it's very easy to understand. It's a branch of science which deal with the study of the force and its effect on the body. Okay, when you are applying force on a body, how that body is responding, that particular analysis is called as mechanics. Now, here very comes the interesting part. Body can majorly be classified under 2 categories. If I say any body, we can classify any body into 2 categories. Can you tell me what could be the 2 categories? And based on that only, we are able to define 2 very important subjects. Exactly. Very good, Harikesh. It will be a rigid body and the second will be a deformable body. Okay. Now, whenever you are applying force on a deformable body, that means you are applying a force and the body is getting deformed. That kind of analysis, where we are studying that kind of analysis, anyone? If you're applying force on a deformable body and you are seeing how much stresses is being induced, how much strain is being induced, right? So that analysis basically you are studying in a very important subject. The first subject that you are studying in our marathon, that is our strength of material. So, right. But whenever I'm talking about mechanics, there we are assuming the body is a rigid body. Okay. Now, question comes to our back of the mind, sir. Do we have any rigid body in reality? Good morning, very good morning. In reality, do we have any rigid body? Yes. That means you are applying force, the body is not getting deformed. Good morning, very good morning. Then how you can say that mechanics is directly related to the practical applications? We are saying that the force analysis on a deformable body is studied under strength of material and the force analysis which studied under rigid body is studied under engineering mechanics. So my question is, sir, how you are analyzing, because on one hand we are saying that rigid body is not actually possible in reality, and we are saying engineering mechanics is one of the very practical subject that you are observing in the daily life. So how you can justify this statement? This was asked in one of the PSU examination. Okay, we are assuming that this is a rigid body, and if you see that major, like 99% of the applications we are always discussing from the engineering mechanics perspective, then how you can justify the statement? Actually, what is happening is, let us suppose this is a pen, right? So definitely while designing, you have already assumed that on this pen max to max 100 Newton of force will be applied. Okay, let us suppose the threshold value or the ultimate point at which the body will be deforming, that is, let us suppose 200 Newton. But this pen is only subjected to max of 100 Newton. So can we assume that this is a non-deformable body? Yes. Can we assume that this is, because its threshold limit is 200 Newton. While designing this pen, I've already assumed which material should be placed, because I know that it will be having a max to max of 100 or 150 Newton. So for taking a factor of safety, we are taking a material which is able to accommodate or which is able to absorb 200 Newton of force. In reality, it is only having only 100 Newton of force is being applicable. So can we assume that it is a non-deformable body? And if I try to apply a force because it is not deforming, that kind of analysis is being discussed under engineering mechanics. Is this clear? This is a major we can say basic understanding you should be knowing about what do you mean by engineering mechanics, because then only you will be able to proceed forward. Is this clear? So after designing of an object, then comes the picture of engineering mechanics, right? If you are, let us suppose, taking a body for the first time and you're applying a force, then that analysis won't be discussed under engineering mechanics. The reason being why it is not be discussed under engineering mechanics, because that could be a deformable or that could be a rigid body, because I don't know what is the maximum threshold value. Okay, yes, definitely, Vansh. I will be telling you starting 2 hours will be for civil mechanical both, and after that it will be dedicated for mechanical. Okay, I've make sure that in the starting we'll be covering the entire syllabus which is common for mechanical and civil both. Then after that, when dynamics will be started, then it is purely for mechanical. Okay. Chalo. So now we have understood that engineering mechanics is a branch of science which deals with study of force and its effects on a rigid body. On a rigid body. Is this clear now? Now you are able to justify this statement. It is a branch of science which deal with the study of force on a rigid body. That means if you're applying, let us suppose there is a rigid body, you're applying a force, then how this body is responding, what is the acceleration, what is the velocity, what is the displacement, that analysis we are basically calculating. Or what is the opposing force that is being applied on the body. So that kind of analysis is being discussed under engineering mechanics. Okay. Right. Now, before entering into the equilibrium conditions or resultant, or we can say the 2 force or 3 force system, let us try to understand what do you mind, how we can classify engineering mechanics. Engineering mechanics can be classified broadly under 2 categories. It is statics and dynamics. Okay. Engineering mechanics is broadly classified into 2 categories. One is statics, second is dynamics. So what do you mean by statics? Yes. What do you mean by this word statics? That means you are applying a force, the body is not moving, the body is at rest. We can say whenever you are applying a force, the body is not moving, body at rest, that will be considered as a static condition. Dynamics means the body is in motion. Dynamics mean the body is in motion, right? Okay, now dynamics is further classified into 2 categories. One is kinematics, second is kinetics. So what do you mean by, what is the difference between kinematics and kinetics? Yes, what is the major difference between kinematics and kinetics? Anyone who can help me out? Many students do have confusion in here also in difference between kinematics and kinetics. Yes. Prince, Leban, Rahul, Abhi, Faninder, Arikesh. Speed and forces. Okay. Darshan is saying speed and force. Anyone else? Yes. Arikesh saying in kinematics, external force is not be considered. Once Harikesh, absolutely correct. We are not considering the force. But tell me one thing. Frankly, tell me one thing. If you want a body to be in motion, okay, if you want a body to be in motion, then you definitely need to apply force. Yes or no? If you want this body to be in motion, I have to apply a force, then only this body will be moving. Yes, then how we can say that the force should not be considered? I have a very legitimate question. If you want a body to be in motion, we have already seen that dynamics means body in motion, and further it is classified into 2 categories, kinematics and kinetics. Kinematics, you are saying that force is not being considered, or without force. I said, tell me one thing, if this is body is at rest, if you are not applying any force, the body will continue to be in rest. Fine. yes, effect is considered. Okay, fine. देखो, अच्छा, can anyone who can tell me what do you mean by this word dry state? What do you mean by this word of dry state? Let's hear out from you guys. Being mechanical as civil students, definitely you might be knowing about this. What do you mean by this dry state? Anyone? क्या होता है dry state? Yes, Ajay, Savvy, Darshan, Prince. Alcohol ban, है ना? Layman, very good. Non-alcoholic state. Acha, tell me which states are dry states? Which states are dry states? Can you name some state? I do remember it is in Bihar, है ना? It's in second state is Gujarat. Very good. Any other? Gujarat and Bihar. I think I only know two. There is one more place. I don't remember exact. My GK is not that up to mark. Bihar and Gujarat, I think, right? Correct. Faninder, no, dry states mean it's not, if I talk about from alcohol perspective, the states where alcohol selling is not legal, that is, we call it as a dry state. Ayodhya, definitely. A portion in UP, Ayodhya, definitely it is not allowed to sell. Right, chalo. Now coming back to our main question. So tell me, if you are staying in Gujarat, so is the person who are staying in Gujarat are not getting alcohol? Definitely they might be getting alcohol from in the black market, might be, right? I'm not sure because I didn't went to Gujarat. In Bihar also, I think some persons might be, if any foreigner is going, they always have in the top restaurants do have for foreigners, they can serve alcohol in the dry state also. They are getting, right? Okay, that means in the dry state, the alcohol consumption is legally, it's not legal, it is illegal, right? If you're getting an alcohol in a dry state, that means it is completely illegal. Same goes with the kinematics and kinetics. In kinematics and kinetics, what is happening? Force is actually present, but considering force in kinematics will be called as an illegal. Okay. Considering force in kinematics will be considered as an illegal. Force is actually present, because without force the body won't be in motion. So let us try to visualize from one more perspective. You might have heard about a very interesting term, we call it as viscosity. What do you mean by this word viscosity? Prince is saying that's a definite it is getting. Okay, he's quite sure with that. What do you mean by this word viscosity? It is basically the property of the fluid. It is a property of the fluid which is allowing the adjacent fluid to avail the resistance. That means there is a relation between the adjacent fluid whenever there is a relative motion. Exactly. Friction related to fluid. Perfect. Very good. Perfect. Now, in viscosity, there is one we call it as dynamic viscosity and one we call it as kinematic viscosity. Yes or no? There is one we call it as a dynamic viscosity, second which we call as kinematic. Achha, what is the unit of dynamic viscosity? Let us see, because there was once a question is asked in engineering service. What is the unit of dynamic viscosity? Tell me in Newton. Quickly. What is the SI unit of dynamic viscosity? And you won't believe this. One question was asked in engineering service, ESC prelims. Poise, Newton second per meter square. Kundan, no, it's not. Correct. I'm getting a lot many variable. You will be having only one SI unit, right? Newton second per meter square. Everyone is agreeing with this? Pascal second. Yes. So Newton second per meter square. Everyone is agreeing with this, right? What is the unit of kinematic viscosity? What is the unit of kinematic viscosity? Quickly. Very good, Shavik. Very good, Akhil. What is the unit of kinematic viscosity? Meter square per second? Everyone is agreeing with this also. Now if you try to visualize, if you want to calculate, this is basically denoted as mu and this is mu. So mu is equal to mu by rho. Basically this is the formulation. Okay, now in kinematic viscosity there is nothing like kg is present. There is no mass being present in kinematic viscosity. If you try to visualize the SI unit, there is no kg component. Okay, so kinematic always means that the mass is not being considered, right? If I say force is equal to, according to Newton's second law, it is equal to mass into acceleration, right? The body, if I say, definitely when a body is moving, right? So it will definitely will be having an acceleration. It will definitely will be having an acceleration. Okay, so if you are considering an acceleration and every body mass will be present, so force will by default be considered. But in kinematics, we are not at all considering the mass component, and that is the reason in kinematics the effect of force is not considered. Is not considered, right? That means by default, back of the mind, why the force is not being considered? Because I'm not considering the mass. Because of the non-consideration of the mass, the force is not considered, and that analysis we called as kinematics. Is this clear? In kinetics, definitely we are considering force is considered. Force is considered, right? Force is considered, right? Okay, force is considered means we are considering the mass of an object. That is the reason force is being considered. Okay, but back of the mind, force will always be present in the system. Even though if you are doing the kinematic analysis, you always remember that force will be present, but as we are not considering the mass, so force effect will not be considered. Is this clear? Right? Understood the major difference between kinematics and kinetics. I've taken an example from the viscosity perspective so that you can understand, visualize, because here if there is no kg, there is no mass, there is no kg in this particular unit, so that definitely means that we are something discussing related to kinematics. And always remember that whenever we are using the word kinematics, mass is not being considered. There is never never ever will be having a kg component. Okay, right? Fine. Now we are discussing about something like force, mass and acceleration. So definitely we know that. What is force? What is force? Okay, so force is equal to rate of change of linear momentum. Basically we can say it is nothing but the rate of change of linear momentum. We'll be discussing this in the later stages also, what is linear momentum. So F is equal to m into a. Mass is considered as a constant, so F is equal to m into a, right? Now if I try to visualize this equation, basically this is the cause. Force is nothing but the cause. This is the reason for a body to be in motion, right? And whenever I'm applying any cause, its effect will be this one. This is its effect. The acceleration is considered as an effect. That means if I say there is a body, if I'm applying a force, due to this force the body is undergoing some acceleration. Then what is this m? Definitely won't be saying it as mass. I know everyone knows this is a mass. What is the physical significance of this? If I say F is the cause, A resembling the effect of due to the force, then what is this m? What this mass signifies? Anyone? Inertia. Very good. Very good. Can we say this is nothing but resistance to change? Let us take an example. Let us suppose I'm having a bottle, identical bottle, and this bottle is filled with water. This bottle is filled with water and this is an empty. This is bottle 1, this is bottle number 2. Okay, I'm applying same amount of force. Let's say I'm applying 10 Newton of force. So tell me which bottle will be offering me a larger resistance, bottle 1 or bottle 2? I'm having two water bottle. One bottle is filled with water, second bottle is empty, and it's a plastic bottle, right? Okay, so if you apply same amount of force, definitely bottle number 1 will be offering me a larger resistance, right? And that resistance to change, we call it as, all of you have already given me the answer, that is inertia. Right? Is this clear? Understood? This particular F is equal to ma. Now you're able to visualize each and everything is having some its own physical significance. Okay, clear everyone? So whenever now anyone is asking you what is mass, what is inertia, it is nothing but resistance to any change or resistance to the change in position, right? If a body is having a larger mass, let's say you're having a train in front of you and if you're having a bicycle in front of you, you are applying same amount of force, definitely train won't be moving because it is offering me a larger resistance. But the bicycle, because it is having a lower mass, it won't be able to offer me a larger resistance, and due to that only we can say the body will be having some effect due to the cause, that is force. Clear? Understood? Now, we are talking about force. We are talking about force. Let us try to classify the different types of forces. Let us classify the different types of forces or classification of forces. The first and the foremost, everyone might be knowing about this, is the coplanar force. Coplanar force. Second one is concurrent force. Okay, there are a lot many combinations, but we'll be discussing the major one because the rest you know. What is coplanar force? NAR, I think. What is coplanar force? Coplanar force means the forces are lying in a same plane. The line of action of all the forces are lying in a same plane. If I say this is your x-axis and y-axis, then all the forces are lying in a same plane. These are all lying in a same plane, right? What is concurrent force? Concurrent force is basically the line of action of all the forces will be having one common intersection point. The line of action of all the forces will be having one common intersection point, that is we call it as concurrent force. Perfect. Third category that we can say is collinear force. Collinear force. In collinear force, what we are having is the line of action are basically in a same line. The line of action of the multiple forces are in a same line. They say this is F1, this is F2, this is F3. So line of action of all the forces are coinciding with each other. Line of action of all the forces will coincide with each other. That is we call it as collinear forces. Right. Now we can have some combination of two. We can have non-coplanar concurrent force. We can have non-concurrent coplanar force. We can have different combinations. Right. So I'm not discussing that because that is very easy to understand. Yes. Non-coplanar concurrent means the forces are not in the same plane, but they are meeting at a one point. Coplanar non-concurrent means the forces are in a same plane, but they are not meeting at a same point. Coplanar concurrent means all the forces are in the same plane and they are having a same intersection point. Okay, so this kind of forces we call it as the different classification of the forces. Is this clear? Right, I think that is not even required also. You are able to answer this very easily. Hai? Yes. Okay. So now let's talk about a very important segment, that is resultant. Hai? Resultant of force. What do you mean by this word resultant of force? Resultant of force basically means it is always possible on a body, if multiple forces are acting on a body, right, then resultant will be indicating a single force that will be giving me the same effect as of that multiple forces. If I say on a body we are having multiple forces, let's say this is F1, F2, F3, F4, there are multiple forces, right? And if I try to write a single force, this will be giving me the same effect as of these multiple forces, individual forces. That will be called as a resultant of the force. Combined effect. Very good, Souvik. Okay, so resultant force is nothing but it's what we can do is we are combining all the multiple forces into a single force. That is called as a resultant force, right? Exactly. Now there are multiple ways to calculate the resultant of resultant force, right? We'll be talking about 2-force system, we'll be talking about 3-force system also, but before that let us try to understand what is equilibrium system. Okay, tell me what do you mean by this word equilibrium. What do you mean by this word equilibrium? Anyone? Let us hear out from you guys. What is the condition for equilibrium? Anyone? Prince, Shovik, Ajay. The body is unstable. Net effect equal to 0. Net force equal to 0. Okay. So can we say if the total force acting on a body, if it is equal to 0, that means we can say resultant force equal to 0, right? That simply means the body is in equilibrium. Can we say like this? Is that so? The total force, that means resultant equal to 0, right? Can we say the body is in equilibrium? No, this is not the only criteria. This is not the only criteria. The moment, the total moment acting on a body also must be equal to 0. These are the two criteria. Then only we can say the body is in equilibrium or in the stable system. Okay, equilibrium means the body will always be having net force acting on a body will be equal to 0. The net moment also will be equal to 0. Then only will be classifying that the body is in equilibrium. But we always try to visualize. That, sir, if we are only calculating net force equal to 0 and the body is in stable system. Why we are saying like this? Because if I say a concurrent force system, let us suppose if I take a concurrent force system. Okay, if I take a concurrent force system, let us suppose I'm having F1, F2, right, F3, F4, something like this. So this is a concurrent force. So here can we say the moment will always be equal to 0? Can we say like this? Because if you try to calculate moment about this point O from the point of intersection, it will always be having 0. So this is not being required. This condition no need to check, because for concurrent force system, this particular system will always, this total moment equal to 0 will always be fulfilling. No need to check. That is the reason on in concurrent force system we are only checking the total force equal to 0 or not. That means the total horizontal force equal to 0 and total vertical force equal to 0. Okay, fine. Because we always try to remember that, sir, total force equal to 0, the body is in equilibrium. That is not a complete statement. This statement is only applicable if you are talking about concurrent force system. If you are talking about a let us suppose I am talking about one system like this, F and F. Tell me whether the body is in equilibrium. Let's say the second example, whether the body is in equilibrium or not. This example, anyone who can tell me? So total force, total vertical force equal to 0, है ना? So total force is equal to, there is no horizontal force, we can say the total force equal to 0. But if you try to visualize, due to these two forces, we are getting a turning effect, which we call it as moment. And here, what do we call this moment? What do we call this moment? Anyone? Exactly, this moment we call it as couple. We are getting a clockwise movement, and this particular moment we call it as couple, and that is equal to F into E. Let's say this distance is E. So F into E will be the couple that is being created, and the body is in motion. Okay, it is not in equilibrium. Very good. It is a couple. Hai very good. Okay, clear? Now let us try to visualize. The two-force system. Two-force system means, let us suppose on a body, if two forces are acting, then how you can calculate the resultant and how you can check the body is in equilibrium or not. Okay, let us suppose we are having two forces P and Q. Very easy. I won't be going for any derivation. In between this, we'll be having one, the angle between these two forces is theta. So here we can use the parallelogram law of forces. parallelogram law of force, right? And let's say this is the resultant force. So this resultant will be identified, will be given by the diagonal of a parallelogram. If you are making a parallelogram, this diagonal will be represented by this resultant. Let's say this angle is phi, right? So the resultant will be equal to under root of p square plus q square plus 2pq cos of angle between these two forces, right? And if I want to calculate what is, because force is a vector quantity, I required magnitude as well as direction. This is the magnitude, I'm talking about. Okay, then how we can calculate the direction? So tan phi is equal to q sine theta divided by p plus q cos theta, right? So now I have identified the magnitude as well as the direction of the resultant force, because we know that is a vector quantity. Okay, fine, because we know that is a vector quantity, so now we can say the body magnitude, the force resultant magnitude and its direction we have calculated. Okay, fine. Now can we say that if you want, this we already have discussed, if you want, let us suppose there is a body, there is an arbitrary body and two forces are acting, let's say P and Q are forces acting, and the angle between these two forces is theta, right? And if you want that the body, how much force you need to apply so that the body will be at rest, can you tell me? How much force you need to apply so that the body will be at rest? Can we say if this is resembling you about the resultant R, if R is resembling the resultant R, so if I'm applying a force exactly of the same magnitude but in the opposite direction as that of R, then can we say the body will be in equilibrium? Can we say like this? Why I have done like this? Because let us suppose, let's take one more example. Let us suppose I'm having a 5 Newton force and a 10 Newton force acting like this. Okay, and I want to make this body to be in equilibrium. So what we can do, we can calculate this to be, what is the resultant force, that is 15 Newton. And if I want to make this body to be in equilibrium, I have to apply a force exactly having the same magnitude as of this resultant but in the opposite direction. Then we can say the body is in equilibrium. So same concept we have applied over here. Whenever you want to identify what should be the force applied on a body so that the body must be in equilibrium, you calculate the resultant force, that magnitude will be required but in the opposite direction of that of the resultant force, then only we can say the body is in equilibrium for a concurrent force system. For a concurrent force system, okay, because here we are not even considering about the moment, because we are talking about concurrent force system. If we are having a non-concurrent force system, then we have to check for the moment condition also. Okay, then you have to check for the moment condition also. Is this clear? Right? All right. Now let us talk about the triangle law of forces, because these are some segments which will hardly take 1 hour to complete, because this is a revision going on. You might have studied this n number of times. Okay, so I'm not investing that much time. We'll be investing more time to those topics which will be slightly complicated for you. Okay, now triangle of forces, it's quite easy to understand. It is more sort of a graphical approach. I can say that if there are two forces P and Q, right? If there are two forces, P force and Q force, then the third side of the triangle will be resembling you the resultant force. Okay, the third side of the triangle will represent the resultant of the two forces, and this particular direction will be the direction of this particular resultant force. And it is somewhere we have already discussed in the parallelogram law also. It is the same thing that we have discussed. This is Q, this is P. So ultimately we have discussed this, the same logic, but only thing, the way of representing is different. Okay, fine. Now we are talking about equilibrium conditions, so definitely we have to talk about one more concept, that is the Lami's theorem. Okay, but before Lami's theorem, let us talk about one polygon law of forces. Let us suppose we are having four forces are acting. Till now we are applying the two force system where only two forces are acting, but let us suppose we are having four forces are acting. Then how we can identify? This is a concurrent force system. There are two ways. Either what we can do, we can understand, we can identify what is the angle being subtended. Let's say this is theta 1, this is theta 2, this is theta 3. So we can take all the horizontal force, make it equal to 0, all the vertical force equal to 0, and we can able to convert it like this. We can able to identify what should be the magnitude of the force in order to make the system to be in equilibrium. If you want to identify the resultant force by using the triangle law of forces or from the polygon law of forces, it's quite easy. Let's suppose this is F1, right? This is the F1 force, right? F2 is this one, right? This is F3. I'm only drawing all the forces in the given direction till this one. Now, if I want to calculate the resultant of all the four forces, that is 1, 2, 3, 4, just you have to join the first and the last point. This line will result the resultant of 1, 2, 3, 4. You are saying, sir, I only want to identify the resultant of only three forces, that is F1, F2 and F3. Then you have to start from F1, join till F3. This will be giving you the resultant of 1, 2 and 3 only. But you want to only calculate only the resultant of 1 and 2. So this line will be giving the resultant of 1 and 2. 1 and 2. Okay, fine. I hope so you know about this, right? So it's very easy to understand. Whenever you are dealing with multiple forces, you go with this condition, total horizontal force and vertical force equal to 0, and you can identify any unknown parameter. But let us suppose if you are getting a 3-force system, very important, and you have to use this one because this will be reducing your calculation time. If you're having 3-force system, देखो, best part of engineering mechanics is a same question can be solved by multiple ways. So it's not mandatory that you have to always select that way which I'm saying. You can select whatever way or whatever concept it is being clear for you. You go for select that to solve the question, because ultimately in the examination it's all about speed and accuracy. It's all about speed and accuracy. Both must be maintained. If you are taking that methodology which you are not comfortable enough, it will be taking more time and ultimately you won't be able to complete the paper. That should not be your objective. Your objective should be which method it is comfortable. You should be adapting that so that you are able to get the best out of that. Okay, fine. Now coming back to the 3-force system, the first and very important concept that we have to understand is Lami's theorem. What is Lami's theorem? If you are having 3 coplanar forces acting at a point, they will be considered in an equilibrium. If they are considered in an equilibrium condition, then we can say, if I say these are P, Q and R forces, so P is directly proportional to the sine of angle between other two. Say this angle is alpha, so this is sine alpha. R is directly proportional to sine of opposite two forces, that is sine gamma. Q is a direct proportion to sine of beta, right? Okay, and you won't believe this question statement was asked for 1 marks in the GATE exam. Statement आया था यार, इतना easy question पूछा था. Okay, so we can rewrite this equation as P by sine alpha is equal to R by sine gamma is equal to Q by sine beta. So whenever you are dealing with 3-force system, better you can use Lami's theorem, because it will be saving your time for calculation, right? It is not mandatory. If I say we are having the same equation, let me write P, Q and R, right? And they have given you this angle as alpha, this angle given as gamma, and this angle is given as beta, right? If you want to use the method of resolution, you can try to resolve the forces in horizontal and vertical direction, and you can solve by using that horizontal force and vertical force, but that will be slightly time taking process. Okay, that will be slightly time taking process. And one thing you always need to remember, that if you are having a combination of force like this, let's say we are having a P force, a Q force and an R force like this. Okay, so you should not be taking, let's say if you are taking P, the angle between other two forces. Better than this, you can convert all the forces are moving either away from the point or towards the point, right? Here we can say this is P, this is Q, this should be R. Now you can measure the angle and you can identify or you can create the Lami's equation. Okay, or else what will be happening, you will be getting error in a sign. Sometimes you are getting one negative sign, and that will be getting a negative marking. Okay, so make sure either all the forces are towards the point or all the forces are moving away from the point of intersection. You try to convert like this, then you try to solve it and the problem will be solved. Okay, a simple technique so as to avoid any confusion. Right, understood? Equilibrium condition, Lami's theorem, all clear. Now one more thing that you need to understand is principle of transmissibility. What is principle of transmissibility? It's quite easy. If you're having a force acting at a point, let's say there is a force F1 acting on a body, then you can move this force F1 along its line of action at any point. But make sure you're not changing the direction. That means if you want to draw it like this, you can draw F1 over here also. But the direction and the length of this particular arrow must be kept constant. That is we called as principle of transmissibility. That means at the state of rest or in motion of a rigid body, if unaltered, if the force acting on a body is replaced by another force of same magnitude and the direction but acting anywhere on the point along the line of action of the prior forces, that is basically we call it as principle of transmissibility. Okay, fine. Chalo. Next is moment. It is nothing but the turning effect that is being created. Already we have taken one example taking consideration of a couple. Fine. So if I say there is a body, there's a, let us suppose a rod, and there's a point A, and there's a force acting. Let's say there's a force acting like this, F. So what is a moment? What is the moment about point A, which is definitely a vector quantity? Yes, anyone? What is the moment about this point A? The moment about this point A will be what the from the line of action, take the perpendicular from this. Let's say this distance is L. Okay, so it will be L cross F. Okay, this will be giving you the concept of moment. L cross F, your R cross F will be giving you this. Because this is a cross product, definitely the moment will be a vector quantity. Okay. Achha, can you tell me what will be the direction? What will be the direction? Anyone? Or if I take this as R, many students will be remembering like this one, R cross F. Yes, anyone? What is the direction? If I say this is I cap, this is J cap, and this is outside the screen is K cap. Yes, here the students are basically committing one mistake. Usually the students do commit this one mistake is they say clockwise or anti-clockwise is the direction. Okay, tell me one thing. Let us suppose there is a disk. There is a disk, right? And it is rotating in this direction. Okay, that means if you are seeing from this end, it is rotating in a clockwise direction. Fine, clockwise. Okay, this is let us suppose I cap, this is J cap, and outside the screen is K cap. This is the direction axis being given. So can you tell me what is the direction of this rotor rotating about an axis? This is a person A standing over here with his eyes over here. What is the direction? Will be saying, sir, clockwise. Many students will be saying, sir, it is a clockwise direction. Let us suppose there is one more person who is standing over here, a person B, right? So tell me what will be the sense of rotation? If a body which is rotating clockwise, when you are seeing from point A, the same body will be visualized as an anti-clockwise or counterclockwise. So tell me who is correct, A or B? Who is correct, A or B? Because you are the third person who is able to see both A and B. Exactly. Both are correct. So you won't be saying the direction is clockwise or anti-clockwise. That is sense of rotation. Clockwise or anti-clockwise is nothing but the sense of rotation. Direction will be given by the right hand thumb rule. Okay, what you have to do is you have to turn your fingers in the direction of rotation. You have to turn your fingers in the direction of rotation. This thumb will be giving you the direction of the rotation. Okay, exactly. So if you try to turn your finger, the direction is on the left hand side, that is the direction of this will be minus I cap. Minus I cap will be the direction of this particular rotation. Sense of rotation is clockwise or anti-clockwise, that depends upon the frame of reference, where from which point you are seeing. The direction is from A to B. Very good. Or minus I cap, because I've already given you the unit vector so as to have better understanding. Clear? Okay. So coming back to this now, tell me, what is the sense of rotation? Sense of rotation is clockwise. What's the direction? Direction is nothing but you try to rotate clockwise, that is inside the board, that will be minus k cap will be the direction of the moment. Okay, minus k cap will be the direction of the moment. Is this clear? Right? Understood everyone? Okay, clear? Eh? So there are some small points that you have to visualize. Okay, fine. Chalo. And this moment is basically the turning effect that we are able to understand. Now, one more thing that we can understand is a couple. I think couple is already being discussed, so no need to take into consideration. Achha, let's take one more example. Let us suppose I'm having a rod. Right? And this is point A, this is point B, this is point C, and this is point D. And applying a force F from this point, right? So tell me, the distance is RA, RB, RC. This is RA, right? This is RB, this is RC. Okay. So tell me, the moment about point A, only the magnitude I'm asking you. What will the moment about point A? Only the magnitude. What is the magnitude of the moment about point A? So that is equal to RA into F. RA into F. RA into F. The moment about point B is RB into F. And moment about point C is equal to RC into F, and moment about point D is equal to 0. So I can say moment about point A is not equal to B, is not equal to C, is not equal to D. That means along the length of a rod, the moment will always be a variable parameter. As you are moving along the length of the rod, the moment is gradually increasing. Okay, right? But let us suppose if I try to take the concept of a couple. Let's say there is a couple acting at this point. Couple, I hope you know what is a couple. It is an equal and opposite force acting on a body. Equal and opposite force acting on a body having some offset E. Okay. So let's say this is, as you are moving away, it is increasing, right? From C to B to A. As you are moving away from the, it depends how you are defining. If you are saying from A to C, it will be decreasing. From C to A, it will be increasing. Okay. Now, let us suppose I need to calculate the moment about point A, about point B, right? And also about point C, right? Let us suppose this distance is X, this distance is Y. Chalo. First of all, tell me what is the moment about point A, quickly. What is the moment about point A? Sir, this force will create a zero moment because it is passing through point A. This will create F into E. So E into F. In an anti-clockwise direction or anti-clockwise sense. Anti-clockwise. Total moment about point A is F into E in anti-clockwise sense. Right? Okay. Let us calculate what is the moment about point B, quickly. 0 plus F into E, that is E into F. E into F, sure. If I try to calculate, this will create a clockwise moment, sorry, anti-clockwise moment. So this will be about point B. Calculate about point B. So we'll be having f into x, and this will be in anti-clockwise. I'm taking anti-clockwise as negative, right? Or let us take this as negative, because anti-clockwise I'm taking as negative. Okay, and this is also minus f into e minus x, right? F into e minus x. So if you try to calculate f into x will become, that is minus f into e. Again we are getting the same formulation. You calculate the moment about point C. You calculate moment about point C. Moment about point C is f into y in clockwise, f into y into clockwise direction, and minus f into e plus y. So that is giving you minus f into e. So if you try to visualize, if you try to calculate couple along the length of a rod, it will always have the same magnitude. If I see over here, MA equal to MB is equal to MC, right? So that simply means if you try to calculate couple along the length of the rod, it will always have the same magnitude. Okay, it will always have the same magnitude. Is this clear? And if you try to calculate the moment along the length of the rod, it will always have a variable magnitude. Understood? A simple statement. Okay. Done, everyone? Any doubt you were having, please do let me know. All clear? Yes. Can we now proceed to the Varignon's theorem? And after Wagners, we'll be starting off with your trusses. Then we'll be going for your friction, I think. After this one, we'll be going for your friction, then trusses. Then civil student will be free to go. Right, now let's go with the Varignon's theorem. What is Varignon's theorem? It states that if you are having the moment of a force about a point, it is equal to the algebraic sum of the moment of its component about the same point. Let's try to understand. Where is that space? Okay. Let us suppose I'm having a point and you're applying a force F, right? And this is the distance L. This is point O and this angle is theta. So how we can calculate? We can say we will be extending the line of action of the force. If you try to measure this distance, this is perpendicular. So this is theta. So this is L sine theta. This is L sine, this distance L sine theta. We can say the moment about point O will be equal to L sine theta into F, right? Or we can say it like this. Let's try to resolve this force into two components. We are having one is F cos theta and second is F sine theta. This distance is L. So I can say the moment about point O is nothing but the, if I try to take the component, if I try to add, it will be giving me the same result. That is basically we called as the Varignon's theorem. The moment of a force about any point is equal to the algebraic sum of the moments of the component of that force about the same point. If I try to calculate the moment about point O, that is equal to F cos theta will be creating a zero moment. Why? Because its line of action is passing through point O. So we are only having F sine theta into L. So we are getting the same result having that of the moments of the component of that same force for the same point. Clear? Fine. Okay. And where we are actually applying the Varignon's theorem, we are basically applying to identify the point of application of the force. Let's try to take one example. Then we'll be going for 1 second, guys. Let me add one slide, or else it will be very difficult for us. 1 second. It will take hardly a minute. Chaliye. Now, yeah. Are you able to see the screen? Please do let me know. Are you able to see the screen? Chaliye. Now, let us suppose I'm taking one example. Right? We are saying that we are having, let's say 10 Newton, 5 Newton and 15 Newton is placed. This is point A, this is B, this is C, and this is D. Let's say this having individually as 1 meter each, 1 meter each, and this is also 1 meter. The total length is 4 meter. Okay, so you have to tell me what is the resultant force acting on the body. It will be in the mock test. We'll be planning for a complete mock test, right? One in there, and that will be going for the practice session. Okay, in that only we'll be going for the practice session, because these are moderate weightage, so not that required to have any additional practice. So what is the total resultant force? Total resultant will be simply 10 plus 5 plus 15, that is equal to 30 Newton. Perfect. But can you tell me where will be the point of application of the resultant force? Where will be the point of application of the resultant force? Can you tell me where it will be acting from A? From A, where will be the point of application of this resultant force? Will it be a center or any other point? Will it be at 2 meter from A or any other dimension? If I'm trying to say the same thing, 30 Newton, what will be the distance? Any other? It won't be at the center. That is a major misconception students are doing. Sir, it will be from the center, and you have to, it will be from the center only if it is a symmetrical body. If the forces are symmetrical, it is not symmetrical. We are having 10, 15 and 10, 5 and 15. It's not a symmetrical force. So definitely it won't be passing through the center. Let us suppose it is passing through X. So we know that Wagnall's theorem states that the individual forces, the moment created about a point, will create the same moment due to its resultant. Right? So we can say, if I calculate moment about point A, that is equal to how much? 10 into 1 plus 5 into 2 plus 15 into 4, or 15 into 3, not 4. Right? And here the moment about point A, if I try to calculate, that is equal to 30 into x, 30 into x. So these two moments will be having the same magnitude. If you try to equate, then you will be getting the value of x. Whatever you are getting, that is a point of application of force from the A side. Okay, that is the point of application of the force from the A side. It won't be at the center. You can cross check. It will be slightly more than that of 2 meter. Why? Because we are having a 15 Newton force, a larger force acting, so it will be shifted on the right hand side. 2.16, perfect. 2.16 meter is the correct answer. Is this clear? And that is the application of Varignon's theorem. That is the application of the Varignon's theorem. Is this clear? Understood? To identify the point of application of the resultant force in a multi-force system. Okay, so do not say directly that it will be at the center. No, it won't be at the center. You have to calculate like this. Understood now? Example. Chaliye. Perfect. Perfect. Done. Now can we proceed? Anyone having any doubt? Please do let me know. Chaliye. So now let's talk about, I think one couple also is there. Couple, I think we already have discussed. The moment produced by two equal and opposite non-coordinate force is called as a couple. Already we have taken one example also into detail. So F and F, this is E. So the moment or the couple will be equal to F into E, or E into F specifically. It's a vector quantity because it's nothing but a moment only. It is a moment only created by two equal and opposite force. That's it. It's a special case of moment. Okay. Right. Chalo. So now let's talk about the supports and reactions. What are the different types of supports and how we can identify the different reactions in the different supports. If I say there are three types of supports, can you tell me what are the three different types of supports in our engineering applications? And in our subject, we are only coming across two types of support. In engineering mechanics, we are only coming across two types of supports only. Anyone who can tell me what are the different types of supports we are having over here? We are having a fixed support, we are having a hinge support, and we are having a we can say roller support. Normally the fixed support application you are studying in strength of material, a bar, something like this, a cantilever beam or a fixed rod, you're applying a force, what will the deflection, that kind of application you are studying in your strength of material, deflection in beams specifically. Okay, fine, right? But we'll be discussing what is fixed support, what is hinge support, what is roller support one by one. Let us try to visualize. Fixed support, if you are having a rod which is inserted inside a wall, something like this is called as a fixed support, right? And normally it is denoted as like this only, right? Now if I say we are having a rod which is fixed at one of the end, definitely we can rewrite this as hinge or pin joint, also both are having the same meaning. Okay, hinge support or pin joint, both are having the same meaning, right? Okay, now let us suppose if you are applying a horizontal force, will this support will be moving? You are applying a horizontal force on a rod. So my question is, will this support will be moving? No. But according to Newton's second law, it stated that if you apply a force on a body, it will definitely will be having some acceleration. If you apply force on a body, definitely it must be having an acceleration. That simply means that there is one more force which we are not yet considering. There is one more force, we call it as a reaction force, and that is being discussed in the Newton's third law. What is Newton's third law? To every action there is an equal and opposite reaction, right? So if you are applying a force on a body, if it is not moving, that means definitely we are having some reaction force acting. So here we will be having a horizontal reaction force, that is Rx, and that will be having the same magnitude as that of the horizontal force, right? Okay, exactly. Now let us suppose I'm applying a force in the vertical direction. I'm applying a force in the vertical. So is my hinge support or is my support, fixed support, moving upward? It is not moving upward. Why? Because there is one equal and opposite reaction force acting on the body, right? Okay, now because due to this force Fy, it will be having slight we can say moment will be created. A moment will be created in this particular direction, Fy into distance L. But is this fixed support is rotating or it is having some turning motion? It is not having the turning motion. That simply means we are having one moment reaction also. Okay, fine. So in the fixed supports, we always have three reactions. We always have three reactions. We are having two reaction forces and one moment reaction. Okay, so in a fixed support, we'll always be dealing with three reactions, that is two reaction forces and one moment reaction, and that is we called as a fixed support. Okay, that is we call it as a fixed support. Understood, everyone? Okay, chalo. Now let's proceed to the second one, that is hinge support. Also we can call it as a pin support. Also we can call it as a pin support or pin joint. Okay, now it is normally being denoted as like this. Okay, now let us suppose I'm having a pin support. There is a rod, it's kept over here. Pin support means if you are having a wooden scale and you are hammering on the wall, something like this. Okay, so it will be having a free motion like this. So it is able to it is able to turn very easily about the pin joint, right? This is called as hinge support or pin joint. Now let us suppose if you try to apply a force in the horizontal direction, is my support moving along the horizontal direction? It is fixed. So definitely we are having one horizontal reaction. If you try to pull this in the vertical direction, it is not moving because it is definitely fixed at the bottom. So it is having one reaction in the vertical direction. But tell me one thing, if you try to rotate this in clockwise or anti-clockwise sense, so is this rod moving, or is this rod having the turning motion? Is this rod AB, if I say this rod AB, is this rod AB having the turning motion? Yes, there is no resistance being offered. Anna, there is no reaction, so I can say if you're turning this, it will be easily moving. So here we can say the total moment will be equal to I into alpha, and you can easily calculate the value of alpha or the moment very easy, because that is not equal to 0, right? Rotation will be occurring, there is no resistance being offered. So in hinge support, we are having two reactions. That is, namely, we are having the horizontal reaction and the vertical reaction. Horizontal and the vertical, right? Let's go with the third one, that is roller support. It is a modified form of the hinge support. Okay, so it is like on the hinge supports we are keeping some roller, just like skating now we are having the skating. So the same way we are having one rod, we are taking the hinge point. Now we already seen that it is free to rotate. Now if you try to apply a force in the horizontal direction, due to this presence of the roller, it will easily move, it won't be offering me any resistance. So I can say here you won't be having any horizontal reaction. But yes, if you try to apply the force in the vertical direction, we will be having one vertical reaction. So in a roller support, it is only having one reaction, right? And namely that is in the vertical direction. Okay, clear? And in the trusses topic, namely, we are always coming across with the roller support and the hinge support. It is always a combination of hinge and roller, always. That is the reason we have discussed this. So now let's talk about some topic, that the friction topic. Then trusses, then civil students will be free to go, because dynamics is not there in your syllabus. Okay, it's not at all there in your syllabi. Right? Right? Okay, clear? Eh? Now, the next one is free body diagram, FBD. We call it as FBD. What is free body diagram? It's a pictorial representation of the number of forces or movement acting on a body. Let us suppose if I say there is a block which is kept on a surface. So we can say that on this block we are having a weight acting downward, we are having some reaction forces. If I say this is a force F1, right? So we'll be having some F. Let us suppose if we're having some reaction force, your frictional forces. So all the forces which is acting on a body, if you try to represent in a pictorial format, that is we called as free body diagram. And in mechanics, we will be using the concept of free body diagram again and again in different questions. Okay, fine. In various problems, we will be coming across the FBD analysis or the free body diagram multiple number of times. Specifically when we'll be starting the friction topic, there we will be using this concept of free body diagram again and again. Okay, clear? So now let's start with the friction topic, right? And then we'll be going with the trusses. So let's go with the friction. Let's go with the friction. Now, what do you mean by this word friction? Anyone? What do you mean by this word friction? Yes. And is this friction good or bad? Tell me. Friction will be saying that opposing force to the motion. It is an opposing force to the motion of a body. A resistive force which is opposing the motion of the body. Exactly. Opposite to the relative motion. Very good, Vinay. Absolutely correct. Friction force is always opposite to the relative motion. Do not say that it is opposite to the applied force. No, we can have some situation where the applied force and the friction force are both in the same direction. We'll be taking some examples for that also. Right? Friction force is not never opposite to the applied force. In general, we can say friction is always opposite to the relative motion. Exactly. Friction is both good and bad. If I say good application, what is the example of friction to be considered as a good? Where we are considering the friction as a good? The best example is walking. If you are walking on a ground, because of friction only you are able to move very easily. Right, because of friction only you are able to move very easily. Application of the brakes. Even if you are using a ballpoint pen, if you are using a ball pen, right, if I say this is a pen, this is the roller. If you try to visualize, there is one ink, there is an ink. Okay, so there is always a roller kept over here. So what is basically happening is, you might have seen that whenever oil is being spilled on a piece of paper, if you try to write with a ballpoint pen, you are not able to write. Why? Because of the oil spillage. What happens if you try to magnify it over here, it will be like this, a roller, right? There will be ink. So when due to the friction, this roller will be rotating and the ink will be coming and it will be coming on the surface of the paper. But due to the oil spillage, what happens? This rolling action is not happening, and due to that, this ink which is present on the surface of the roller, it will stay over there only. It won't be coming downward, right? Right, and that is the reason you might have seen that on a plastic on a plastic coating, right? If you try to write with a ballpoint pen, you are not able to write very easily. Okay, the reason being the friction is being decreased. If you want to hold this pen, because of friction only you are able to hold. If you try to apply oil over here, the friction will decrease and this particular pen will be falling down. This is the good part of friction. But if I talk about the bad part, definitely whenever the friction is coming, you always will be coming across the heat dissipated, and whenever there is a rubbing action between the metallic elements in a moving part of a machine, it will always increase the temperature of the moving element, and that will make increase the thermal stresses being induced, and that will decrease the life of that particular machine element. That is the reason friction is basically considered as a necessary evil. Okay, that is the reason friction is considered as a necessary evil, because in some application without friction you won't be able to understand, you won't be able to use that particular application, but in some cases friction is actually deteriorating the life of that particular component. Okay, clear hai? Understood? So now we have seen that friction is a force distribution at a surface contact between the two bodies that prevents or impedes the sliding motion of body one relative to one another. That means whenever there is a relative motion between two surfaces, always the friction will be coming into picture, right? Always the friction will be coming into picture. Now, friction is basically classified under two categories. We are having a static friction and we are having a dynamic friction. Let's try to understand what is dynamic, or sometimes we call it as kinetic friction. Okay, kinetic friction means the body is in motion. Okay, static friction means you are applying a force, the body is at rest. Due to friction only the body is at rest. That is we called as static friction. But let us try to understand in detail what and how the friction can be defined, right? Let's try to understand. There's some space over here. Now let us suppose if I try to place a body on a flat surface. Let us suppose I'm trying to place a body on the flat surface. Okay, if I want to draw the free body diagram, actually what is happening, if I try to magnify, there is a multiple point contacts, right? So at each and every point we'll be having the normal reaction. So if I try to add, this is the CG point, this is the weight of the body, right? And the total normal reaction will be passing through this, and the body is at rest. If I'm keeping a box, let's say this is the box, I'm keeping it on a flat surface, it will stay at that point. I'm not applying any force, right? But let us suppose if I try to apply a force, if I try to apply a force in this direction passing through the center of gravity, okay, CG point. Now if I try to draw the free body diagram, we'll be having one weight, right, one normal reaction, okay, this is the center of gravity G, and CG point, okay, and this will be the friction acting at the contact point. At the contact surface, the friction will be acting. So tell me, if I say you are applying a force, but that is not sufficient enough, the body should be moving. Let us suppose the force applied is 10 Newton, and in order to move this body, you need to apply a force of friction force or limiting friction is equal to 100 Newton. That means you need to apply a force of 100 Newton, then only the body will be moving, right? You are applying a force of only 10 Newton. So tell me, the body will be static or dynamic? The limiting force or limiting friction is 100 Newton. You are only applying 10 Newton. What will be the condition of this body? Static? Yes? Can we say the body will be in static condition? Yes? Static means the body is in equilibrium, right? And body in equilibrium means the total force and total moment will be equal to 0. Yes? Total force and total moment will be equal to 0. है ना? 1 second. Right? But tell me one thing. Okay, let us suppose, sir, here total horizontal force equal to 0, F will be equal to small f, and total vertical force equal to 0, we can say your W is equal to N. Perfect. But what about the total moment about the center of gravity? Is it equal to 0? If I try to calculate the moment about point G, is it equal to 0? Tell me. Yes. No, right? The applied force, the normal reaction, and the weight is passing through the center of gravity, but friction force is not passing through the center of gravity. That simply means this is not equal to 0. Then how you can say the body is in equilibrium? Then how you can say the body is in equilibrium? Are you able to understand the question? Yes, are you able to visualize the question? My question is, 100 newtons is required to move this body. You are only applying 10 Newton, right? You're only applying 10 Newton. So definitely by logic, this body should not be moving. It should be in equilibrium. Then how you are coming to a conclusion that the total moment is equal to, it is not equal to 0. The friction is creating a clockwise movement. That means if you are trying to apply, let's say 1 Newton of force, the body will be toppling automatically. Is it happening like this? The body will be turning like this. You apply 1 Newton force or 10 Newton force, the body will automatically turn like this. It is not happening. That means there is slight misinformation that we need to rectify. There is slight misconception that we need to understand from the logic perspective. Is this clear? Understood where is the problem? Exactly, correct, Vinay. The free body diagram is not correct. Initially, when no force was applied, at each and every point, the normal reaction was applying, and if you try to calculate, the total normal reaction was passing through the center. No problem. But here, as you are applying force F, what is happening is, if you try to visualize, if you try to apply a force F, in reality, this is the center of gravity, the weight will be passing through this only. In reality, what has happened? The normal reaction has been shifted slightly on the left hand side. Why? Because the normal reaction will be acting like this. It will be increasing as you move. So if you try to draw the actual real free body diagram will be like this. Okay, this is the friction force, right? Now if you try to visualize, now we can get a condition, so total force equal to 0, even total moment is also equal to 0. If you try to calculate moment about point G, what will happen? This normal reaction will create an your anti-clockwise, and F will create a clockwise. Now we are able to get total horizontal force, total vertical force, and total moment equal to 0. We are able to get that condition. Is this clear? So in reality, our actual real free body diagram will be like this. But we never draw a free body diagram like this. We always say the normal reaction is passing through G. We always say that the normal reaction is passing through G. Yes. Okay. In reality, it is being shifted by some offset X. But during calculation, we are never ever drawing a free body diagram like this. Why? Because we are always coming across smaller body. Whenever if I say we are applying 10 Newton force on a body, are we talking about the dimension of the body? We are not talking about the dimension of the body. We are considering this to be a very small dimension, and this is almost tending to 0, and that is the reason we are assuming that almost it is passing through the center of gravity, right? So this is also correct for smaller bodies, only for smaller bodies. Okay, definitely it will be having a very elemental shift. This X will be very negligible, but we have to consider this only if you are having a significant dimension. Sometimes what they'll be doing, they'll be giving you the height of a body, h, they'll be giving you the breadth of the body. There we have to consider the shift of the normal reaction, and there we will be talking about the condition for toppling. Okay, there will be talking about the condition for topple or toppling effect. Exactly, Vansh, we are neglecting because this X elemental shift is tending to 0. This dimension is very negligible. This shift will be so much less that even if you try to take into consideration, that will be approximately 10 to the power minus 8, 10 to the power minus 9 in that particular range. So if you are considering that, almost it will be coming to 0. That is the reason whenever we are drawing the free body diagram of smaller bodies or bodies where dimension is not being given, we can draw it like this and we can proceed further. But if they are giving you the dimensions of the body, then definitely they are asking you from the toppling effect perspective, and definitely we'll be talking about that also. We'll be talking about that toppling effect conditions. What is the condition for topple? We'll be talking about that also. Is this clear? Understood? Okay, chalo. Clear hai? Now let's talk about the friction. Now let's talk about the static and dynamic, and definitely in dynamic also we are having under this two categories. We are having a sliding friction and we are having a rolling friction. Rolling friction. Okay, right? Fine. So let us first of all talk about the static and dynamic, and in detail we'll be talking about the sliding friction. Rolling is very easy to understand. We'll be taking at the end of the session. Okay. So let us first of all concentrate on static and dynamic. Dynamic means we are talking about the sliding friction, right? Now, if I say if you are applying a force on a body and the body is having the tendency to move on the right hand side, let us suppose, then the friction force will be acting on the left hand side, because the friction force is always opposite to the direction of a relative motion. Okay, it is not opposite to the direction of applied force, because let us suppose if you are having a condition like this, there's a body which is having a higher weight, right, and you're applying a force in the upward direction and the body is trying to move in the downward direction. So in this case, the friction force and the applied force both will be in the same direction. Okay, so never ever you should be saying that the applied force and the friction force is always in the opposite direction. We can have a condition where the applied force and even the friction force are in the same direction, like this. Okay, Fine. Is this clear? Chalo. So now let's talk about this particular animation. Now if I say in this particular example, Fa resembles your applied force. Okay, and Ff is your frictional force. Now in the first scenario, in case number 1, if you try to visualize, a person is trying to apply a force even though the body is not moving. He is starting from 0, increasing to a magnitude, and till maximum value it is applying and the body is not moving. But in the second case, what is happening? The person is applying the force and he is able to move this body very easily. So in this particular application, when you are applying a force, the body is not moving, we call it as a static friction, right? And in the second case, when you are applying the force and the body is moving, we call it as kinetic friction. Kinetic friction, okay, or dynamic friction also we can say. Is this clear? So let us try to understand what is the major difference between this and how of the frictional force. Can we say like this? That is the reason the body is moving, right? The same will be the friction force. The same goes with the frictional force. The case number 1, that is the static friction. Okay, is this clear? Right? Chalo. So now let's talk about one example. Let us suppose I'm having a body, right? And this body is require 100 Newton to move. The limiting force is 100 Newton. The same example that we have discussed initially. The limiting force required to move this body is 100 Newton. And we are applying a 10 Newton force. Okay. This is a weight W. This is a normal reaction. And this is the friction force. So tell me whether the body will be in static condition or dynamic. You are applying a 10 Newton force, the limiting force required is 100 Newton. So question is whether the body is will be in static or dynamic. Static, sir. Very easy. It will be in static condition, right? Okay. Now we have increased from 10 to 80 Newton. Now we are applying 80 Newton. What will happen? Still it is in the static condition. That means slowly we are increasing the applied force from 0 to 10, 20, 30, 40, 60, 70, 80, even till 100 Newton. It will be in the static condition. Till 100 Newton it will be in the static condition. But once it surpasses the limiting force, the body now will be having a net force, and due to the net force the body will be moving, right? And the friction force will be surpassed, right? So if I try to plot this in a graph, if I try to plot this on a piece of paper on a graph, if I say on the y-axis, this is the on the x-axis we are having the applied force, and on the y-axis we are having the frictional force. Okay, so as you are increasing the force from 0, the body is at rest. It is exactly with the frictional force and will be reaching the threshold value or limiting force. This is the limiting friction, right? Till this point, the body will always be remaining in the static condition, right? But once it surpasses the limiting friction, it will be having a slight drop and the body will be having a dynamic or kinetic friction. Okay, the body is moving. Body is moving, right? And in this case, even you apply a high amount of force, the friction force will always be remaining constant, right? That is basic reason we are having this called as kinetic. Okay, but in static region, how much force you are applying, the same will be the friction force. How much force you are applying, the same will be the friction force. That will be undergoing till the limiting part. Fine. Is this clear? Now our question is, what is the reason for friction to happen? Why the friction is happening? Can you tell me what is the reason for this? Why we are facing friction. Why we are having friction between the two surfaces? Anyone? Quickly, 1 second, guys. Surface roughness, perfect. 1 second. Yes. Surface roughness, perfect. Any other reason? We are having surface roughness. Yes, perfect, due to surface roughness. Is the surface roughness only reason for friction? Due to the traction between the surfaces, okay. Yes. Is the surface roughness only reason for friction? If that's so, let me take one example. Let us suppose we are having a glass sheet. We are having a glass, right? We are having a glass sheet over here, and there's one more glass sheet. There are two glass sheets. You are placing one over another. And if you try to pull one glass sheet from the side, are we able to move that glass very easily? Because on a glass surface, the surface roughness is slightly less. We're not having that much of high surface roughness. Yes. So my question is, if surface roughness is so less, still we need to apply a very high amount of force. What is the reason? Anyone? Or if you are taking two steel sheets, right? If you are trying to pull the topmost sheet, then my question is, why we need to apply a high amount of force even though the surface roughness is too low? Yes, you are saying the friction is basically due to the surface. That is correct. But surface roughness is not the only reason. Medium changes, exactly, due to the chemical bonding. Due to the chemical bonding, right? Due to the chemical bonding between the surfaces, due to that chemical bonding between the surfaces, we are having a huge forces because of, if I try to visualize, because this is almost smooth surface, what will happen? We will be having a multiple contacts, will be having a multiple bonds will be created, chemical bonding will be created. If you're having a rough surface, then what will happen? We won't be having that much of high chemical bonding, right? We'll be having a very less point to point contact, but because of almost smooth surface, we'll be having a high number of contact between the two surface, and due to that we'll be having a high chemical bonding. And if you want to move this surface one over another, you need to apply high amount of force, and that is the reason you might have seen that when you are placing one sheet on another, if you try to pull it, you need to apply slightly high amount of force. Okay, is this clear? Presence of vacuum is also one of the reason, but yes, because of the chemical bonding also, the friction is also being considered. The friction is actually present between the two surfaces, right? Okay, understood? Fine. Okay, so now let's try to talk about some important statements from the laws of friction. The force of friction always acts in the opposite to which the body tends to move. Definitely, we have already seen that. Till the limiting value is reached, the magnitude of friction is always exactly equal to the force which tends to move the body. That means till the limiting force is being reached, that 100 newtons is being reached, whatever force we are applying, the same amount of friction force will be exhibited. The magnitude of the limiting friction bears a constant ratio between the normal reaction and between the two surfaces. That means they are saying that the limiting friction is directly proportional to the normal reaction. If you try to remove that proportionality sign, we are getting one very important parameter, that is the coefficient of friction. Mu s resemble the coefficient of static friction. Coefficient of static friction. Okay, yes. Sir, in case of moving car, is the criteria same? So in the case of moving car, you might have been seen that whenever we are having, you might have seen that whenever we are filling up the air in a car or any automobile, we are not filling up to the maximum value, right? We try to have slightly lesser pressure, like we are having 35 psi, that kind of pressure in the in we can say cars front wheel and back wheels, we're having different psi, 30 or 25 sometimes, right? Why we are not able to, why we are not filling up the complete air? The reason being, when the car is moving, if the air inside this is completely filled, due to the heat it will be expanding, right? And there's a chances of explosion. There's one more reason why we are having a lesser this one, because if you try to have a complete fill air, the contact will be less, and due to which the friction, the traction force will be slightly less. If you try to have a slightly less air, then what will happen? We'll be having a slight area contact, they will be having a larger area, right? And due to that, the effective contact will be more, and due to which the traction force will be increasing, and that will be responsible for the easy and quicker motion of the body. Okay, right? Fine. Is this clear? So definitely in cars also we are using this, but in that case the surfaces are quite rough. Because of the rough surface, and you might have seen that when in the older tires, when it is almost about to throw, it is almost plain. New tires are quite rough. You might have seen the lines also. Why we are making a rough surface? Because there is a rough surface, the more the traction force, the more easily we'll be able to move that vehicle. But if you are using an older tire, you might have seen that the chances of sliding is more, or skidding chances are more. If you try to apply the brake, the chance of skidding are very high in the older tires. New tire may chances will be very less. Okay, fine. So basically we are increasing or decreasing the surface roughness. Okay, now the force friction depends upon the roughness or the smoothness of the surface and the chemical bonding between the surface. Now the last statement, they are saying that the force of friction is independent of the area of contact between the two surfaces. Sir, how we can say? Because if you are having a larger area, then you will be having a larger friction force. We always have this perception. Let us try to take one example. Let us suppose I'm having a body having weight W. This will be the normal reaction, right? This will be your frictional force, this will be the applied force. So we can say friction force is equal to mu into N, right? Now what I'm doing is I'm increasing the area, right? I'm increasing the area. Okay, so basically if I try to remove this one, the N1 into there, let's say there is 5 points of contact, 1, 2, 3, 4 and 5. In total we will be having 1 N, right? Clear? Now what I'm doing is I'm increasing the area of contact by keeping the same weight. I'm increasing the area of contact, but the weight is kept same, because I need to check the criteria for the area of contact. Okay, fine. So what is this? If you try to apply a larger area, so the multiple point of contact will be increasing. Let's say we are having 1, 2, 3, 4, 5, 6, 7, 8. 8 points. In total, if I try to add this 8 normal reaction, it will again be having the same. So the friction force, that is equal to mu into N, is also same. So that simply means if you try to increase the area keeping the weight same, that simply means per point contact the normal reaction will be decreasing, but the total normal reaction is still the same. That is the reason we are saying that the force of friction is independent of the area of contact. Okay, that is the reason if you are increasing the area keeping the weight to be same, that won't be changing the friction force. The friction force will still be remaining the same. But if you are increasing the weight also along with the area, definitely the friction force will be changing. Okay, right? Is this clear? Understood? Okay, sure. So now we have understood that so limiting friction is equal to the static friction into N. Now let us take one example and now you guys gonna tell me the answer. Let us suppose we are having a body whose weight is 10 Newton, the coefficient of static friction is 0.8 and you are applying a force of let us suppose 5 Newton. So tell me what will be the magnitude of the frictional force? What will be the magnitude of the friction force? Quickly, what is the magnitude of friction force? F value. Yes. Vinay and Faninder saying 5 and 5 each. What about the other? Quickly. What will be the magnitude of the frictional force? 5. So let us calculate the limiting friction, that is equal to mu s into n, that is equal to 0.8 into 10, that is equal to 8 Newton. That means limiting friction is equal to 8 Newton. Limiting friction is equal to 8 Newton, right? And you are applying 5 Newton. That means we are talking about the static condition. You require 8 Newton to move this body and you are only applying 5 Newton. That means we are talking about the static friction. We are talking about the static friction, right? If you are talking about the static friction, in that scenario, we know that whatever will be the force applied, the same will be the applied force, that will be the friction force, and that is nothing but the 5 Newton. Okay, do not say that it is 8 Newton. If you are saying 8 Newton, that will be wrong. 8 Newton is a limiting friction. That is the force required to move this body. That much amount of force is required to move this body. That is a limiting force, right? If I try to draw the diagram, this is the limiting force, that is your 8 Newton. Okay, this is your applied force, this is friction force, this is your 8 Newton, and you are applying only how much? 5 Newton, and 5 Newton के लिए 5 Newton friction force. All right, fine. Now the second doubt students will be having, sir, why we are having a slight drop over here? Anyone who can tell me why we are having a slight drop in the kinetic region as compared to that of static region? And that is the reason the static friction, coefficient of static friction is higher than that of coefficient of kinetic friction. Anyone who can tell me why in case of kinetic region the mu k, the friction is having slight, not that significant. If I say the limiting friction is 8 Newton, then the kinetic friction might be 6 Newton or 7 Newton, slightly less. But my question is why it is having slight drop from the limiting. Why we are having a slight drop from the limiting? Yes, quickly. Yes, everyone. Tends to move. Okay. Yes. Momentum decrease in the initial. Okay, what is happening is when the body is in motion, because we know that in kinetic part the body will be in motion. When the body is in motion, right, then what will happen? Your body will not have that effective point of, because when the body was at rest, let's say there are body is at rest, let's suppose there are 100 point of contact, and due to that the chemical bonding will be increased and the definitely the surface roughness. But once the body is in motion, let us suppose the effective point of contact has been decreased to 90, let us suppose. So definitely if the effective point is decreasing, chemical bonding will be decreasing, and definitely when the body is moving, the body won't be having sufficient time to make chemical bonding, and that is the reason we are having a slight drop in the friction part. We are having a slight drop in the friction part, exactly, and that is the reason the coefficient of kinetic friction will be slightly less than that of the coefficient of static friction. Okay, right? In a very easiest way possible, we have understood what is the difference between static and the kinetic friction. Okay, Is this clear? Okay, perfect. Clear hai ye cheez? Anyone having any doubt? So now let's talk about what is I think angle of friction. We'll be talking about that. Then we'll be proceeding with angle of repose. Then trusses. Then civil. Almost we have completed. Then we'll be continuing with the dynamics part. Okay. So next is angle of friction, that is noted as phi. What is angle of friction? Let us suppose I'm having a body, right? And let us suppose. Let me draw a diagram over here. This is the weight W, this is the normal reaction, this is the frictional force, and this is the applied force, let us suppose F. Okay. So angle of friction is nothing but if you take the resultant of normal reaction and the frictional force. If you take the resultant of the normal reaction and the friction force and the angle between the resultant and the normal reaction, that angle we call it as the angle of friction. And it's very important because many number of times they won't be giving you the coefficient of friction, rather than they'll be giving you angle of friction. And this is quite helpful in the wedge friction concept. In for mechanical students, we'll be studying later on the wedge friction, so you might be able to understand how important this angle of friction is there. Right. So I can say that if I say this is the normal reaction, this is the frictional force, this is your resultant of these two, this angle is angle of friction. If you try to calculate tan phi is equal to your F by N. And what is F by N? F by N, because this is limiting friction, I'm talking about limiting friction. So F by N is nothing but mu s. So tan phi is nothing but the coefficient of static friction. That means sometimes they'll be giving you angular friction. So from there, you can easily calculate the coefficient of static friction. Let us suppose they are giving you phi is equal to 30 degree. Then mu s will be equal to 1 upon root 3. Okay, 1 by root 3. Is this clear? That is the reason they are giving you. It's also a property of the surface. Just like mu, phi is also the property of the surface, because this is directly resembling you about the coefficient of static friction, right? Now the next one is angle of repose. What is angle of repose? Let us suppose I'm having a body, right? You are keeping on a flat surface, horizontal surface. Now as you are increasing the angle, there will be one angle at which the body will just start to slide down. There will be one angle about which the body will just start to slide down. That particular angle of inclination at which the body will just start to slide down, that particular angle we call it as angle of repose. Okay, so let us suppose this is the angle of inclination at which the body is just about to slide down. Just try to draw the free body diagram. We'll be having this as the normal reaction, right? This will be your W. This will be your W. This is W cos theta. This will be W sin theta. And the bodies tend to move downward, so the friction force will be upward, right? So I can say the total, and this is the limiting friction because the bodies tend to move downwards, just about to move. Okay, now whenever we are talking about limiting condition, there is one more terminology that we'll be using is impending. The body is impends to move down, that means it's about to move, right? So total horizontal force equal to 0, so the limiting friction is equal to W sin theta. Total vertical force equal to 0, N is equal to W cos theta. If you try to take the ratio, I can say tan theta is equal to FL by N, that is nothing but mu s. So here we can say tan theta is equal to mu s. So I can say that the angle of repose is equal to the coefficient of static friction. Okay, let me take one example, then you will be able to have better understanding. Let us suppose they have given you one inclination, theta is equal to 15 degree, and this is the body, mu s is equal to, let's say 1 upon root 3. So tell me whether the body will automatically slide down, yes or no? Due to its own weight, will the body will be sliding down? Yes. Nothing, no weight is given, nothing is given. They're only asking you due to its own weight, whether the body will slide down. Anyone? Yes or no? They are not giving you the weight, they are only asking you by the angle and the coefficient of friction. Why no? Why no? Perfect. Exactly. Very good, all of you. It's absolutely correct. The body won't be sliding down, because if you try to calculate the angle of friction, tan phi is equal to 1 upon root 3. So phi is equal to 30 degree, right? Exactly. So here we can say that over here the angle of inclination, inclination is less than the angle of repose. That simply means the body will be staying there only. The body won't be sliding down due to its own weight. But if you're having a scenario opposite, let's say this is angle 45 degree, then we can say as the angle of inclination is more than that of angle of repose, now I can say the body will slide down. Will slide. Okay, is this clear? The body will slide down, definitely. Understood? Clear, everyone? Angle of repose, angle of inclination, and your okay, fine, because after that we'll be entering into the trusses, and we will be completing the civil portion, then we'll be starting the dynamics part. Okay, dynamics, then your collision topic, then we'll be going for this one, Lagrange's, because many students will be having doubt in Lagrange's. Okay, now let's talk about the next topic, that is trusses, and we'll be completing in one go, right? We won't be taking break, we'll be completing by 2, maximum 2:30, not more than that. Now trusses, where you are seeing this trusses, if you try to visualize the on your screen, we are able to see some combination of different members, combination of different members you are able to see, right? This is basically we called as trusses, and it is basically used to have a rigid support. It is used to have the rigid support. It is used to construct bridges. It is used to construct the roof and roof heads, right? And that is always, if you try to visualize, it's always a combination of triangles only. It is always a combination of triangle. Different triangles collectively, if they are joining, we are getting a rigid support, and that is we call it as trusses. If you try to visualize from theory of machine perspective, the degree of freedom of a triangle is always 0, and that is the reason we are calling this to be a structure. Okay, that is the reason we are calling this to be a structure. Okay, is this clear? Now in the trusses topic, there are two methods for because ultimately in trusses there are two types of question you can expect. One is they will be asking you what is the force being induced. Let us suppose you are applying some forces over here, then how much force will be induced in this member, or how much force will be induced in this member. That type of question they will be asking you. Second type of question is from the zero force member. Okay, so to identify the zero force member, there are some short tricks that you need to understand, and using that short tricks you will be able to get the answer very easily. Okay, so those two topics will be discussed right now. So trusses, we know that it's a framework that is composed of straight members joined at their ends to form a structure. We call it as truss. Trusses is used for supporting a moving or stationary load, bridges, roof supports, and others such as and other structures are the common examples of the trusses. Okay, so basically we are using this for a rigid support, like the bridges, the roof supports, even the stand. If you want to make a stand, we are using a combination of different straight members which is able to absorb the load, right? Okay, so if I talk about the trusses, now what is happening is, it is very much essential you need to have the understanding of trusses. Why? Because if you are not appropriately having the number of members is being done appropriately, there's a high tendency that that particular bridge will be collapsing. If you try to visualize, there are different members where the stress induction is very high, right? If you see here, we are having some red areas, we are having the red areas. So you always try to make sure that these members must be made up of we can say a rigid material, or we can say a stiff material, so that it is able to absorb a high amount of force being induced in that. And it's very much essential. This type of stress analysis is always done before the actual construction of any bridges, because it's very much essential. If you're having some area where the stress concentration is very high, we always need to have high stiffness or high strength material should be used at least at that portion. Okay, definitely, let us talk about that also. Yeah. Now, students do have a doubt, sir, frame or truss mein what is the major difference? Now, if I say we are taking one member, okay, we are taking let us suppose we are taking one member over here, okay, or let me take one straight member. If you try to apply force only at the center, these are the support, then can you tell me what will be the reactions that we'll be getting? You'll be getting we can say a bending force, bending moment. You'll be getting a bending moment in this case. No, you'll be getting a bending moment. This particular shaft will be bended, or this particular beam will be bended, right? Exactly. If I try to calculate f by 2 and f by 2, right? Let us suppose I'm taking one example where this is, we call it as a beam, where we are having only bending moment, we call it as beam. Now, let us suppose I'm having a different combination of the beams or members, and you're applying a force like this. You're applying a force like this. Here you will be having your bending moment will be present, right? You will be having the axial force or thrust will be present. Axial thrust will be present. You'll be having the shear force will also be present. Here bending moment and also shear force will be present, right? Okay, this is basically when your bending moment, axial force and shear force is present. This kind of structure we call it as frame. Okay, in trusses we always need to apply force only at the joints. So if you apply force only at the joint, it is only having axial forces or axial thrust will be present, and due to that we are calling it as truss. Due to that we are calling it as truss. Okay, in a beam will be always will be having a bending and a shear force or shear stress will be induced. In a frame, all these in bending moment, axial thrust and shear force will be present. In truss, only axial thrust will be there, because the forces are acting at the joint, so all the force will be induced in the members in an axial direction. Okay, we won't be having any bending or shear force, and that is a major difference between truss and frame. That is a major difference between truss and frame. Okay, and this is the only condition that you need to there's only one assumption that we need to have. In the trusses, the external force are always acting at the joints. The external force are always acting at the joints. That is the major criteria that need to be fulfilled. Okay, clear? All right. Now, coming back to the trusses topic, already we have seen the different types of supports: the rigid support, your fixed support, your roller support and hinge support. In trusses, we always take the combination of hinge and roller support. We always try to take the combination of these two only. Okay, so in case of trusses, there are three different types of trusses that we need to understand. We are having a perfect truss, we are having a deficient truss, and we are having a redundant truss. What is the meaning of this? We're having different names also: stable, or we can say unstable, or collapsible, or indestructible, or indeterminate truss, but usually we are using this terminology in general, right? What is a perfect truss? If you're having this condition, m is equal to 2j minus 3 being satisfied, where m is a number of members, right? And J is the number of joint. If this condition is satisfied, that is LHS equal to RHS, this type of truss we call it as perfect truss. If you try to take one example, let us suppose we are having a 3-member rigid structure. Here M is equal to 3. You calculate number of joints. There are 3 joints. You can place it over here. 6 minus 3 is 3. So 2j minus 3 is also 3. So it is an example of a perfect truss, right? And that is the reason you might have seen that whenever we are having any rigid structure, it is always a combination of triangles only. We won't be having a rectangle or a rhombus. Always you can see that it's a combination of rectangles only. Okay, now what is a deficient truss? Let us suppose the number of members are not sufficient enough. If the number of members are not sufficient enough, that means M is less than 2j minus 3, that is called as deficient or a collapsible. That means that won't be having any stability. Let's take an example. Let us suppose I'm having a 4-member. Calculate number of members. A number of members is equal to 4. Calculate 2j minus 3. 2j minus 3 is number of joint is 4. 8 minus 3 is 5. So M is less than 2j minus 3. That means number of members are not sufficient enough to withstand the load. That is the reason we are calling it as a deficient or a collapsible truss. Okay, deficient or a collapsible truss. The last one is redundant truss. In this case, there will be extra number of members more than that required. That's we can say extra factor of safety. Okay, let's say we are having a member like this. Let us suppose I'm having a member like this. Okay, so this is member 1, 2, this complete is 3 and this is 4. So M is equal to 4. Number of joints 1, 2, 3, 4. So J is equal to 4. So 2J minus 3. This is 8 minus 3. That is equal to 5. Okay, 1, 2, 3, 4. Okay, 1, 2, 3. So 2J minus this is 8 minus 3 is 5. So M is, okay, let us do one thing. Let us have an additional members to increase the stability, or let us do one thing. Let us try to draw a diagram like this. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, J is equal to 5. So 2J minus 3, that is 7. M is equal to 4. So M is less than 2J minus 3. So here if you try to apply a force, it will be definitely collapsed, right? It is a collapsible or deficient truss. Okay, if you are having members like this, where the number of members, if it is more than that of 2j minus 3, in that case we will be having a we can say a redundant truss. In that case we will be having a redundant truss. That means that is highly stable, which we are using for the construction of bridges. Okay, is this clear? 1, 2, 3, 4, 5, 6. Chalo, perfect. Right? Different type of trusses. Now, truss analysis is basically done under 2 categories. Okay, there are 2 types of analysis of the trusses. One is the method of joint, and second is the method of section. Method of joint and method of section are the 2 different types through which we can analyze any trusses. And to do analysis of the trusses, there is one important factor that we need to understand. What is the nature or type of force? Nature of force. There are 2 nature of forces. Either we can have a tensile in nature or we can have a compressive in nature. Tensile in nature or compressive. Let us suppose we are having a member. We are having a member AB. We are having a member AB, right? Okay. And we are always calculating the internal forces. So whenever we are talking about this, Okay, so here if you try to take point A, joint A, so this force is coming towards the joint, so this kind of force we call it as compressive force. If you're having a scenario like this, A, B, you take joint A, the force is moving away from the joint, this is we call it as a tensile force. And we are using tensile force normally for easy calculation, we are taking tensile force as positive and compressive as negative. It's not mandatory, you can take tensile as negative also, but it's up to you. But standard nomenclature is we always take tensile to be positive and compressive force to be negative. Okay, now before understanding method of joint and method of section, you need to know how you can calculate the reaction forces, right? So let us take one example. Let us suppose we are having a truss and the force is applied only at the joint. Let's say this is the joint where the 10 Newton force is being applied, and you need to calculate what is the reaction force at A and B. Now tell me at point C how many reaction force will be present at point C. Because that is a roller support, it will always have only one reaction. Let's say this is RC. But point A is a hinge support, it will be having two reactions because this is a hinge support, that is RA Y and RAX. Okay. Now, if I try to visualize, when you take the total free body diagram of the complete structure, we can say that total horizontal force equal to 0. So, RAX is equal to 0. There is no other force to support. So, directly we can say this is equal to 0. Right. Let's suppose this is an isosceles triangle. So, I can say that RAY plus RC is equal to 10. You can calculate moment about point A, you can calculate RC and RY. Because this is a symmetrical body, we can directly say RAY is equal to RC is equal to 5 Newton. If this would not have been a symmetrical body, then you have to calculate moment about point A, then you can calculate the value of RC. Once RC is calculated, you can place it over here and get the value of RAY. A simple way. Okay, once the reaction force you have calculated, then you have to take the first method, that is method of joint. What is method of joint? You have to take the equilibrium condition at each and every joint. Okay, let us suppose I'm taking joint A. Okay, because RAX equal to 0, so let me now remove this because it is having a 0 magnitude. I'm assuming all the forces to be tensile in nature. This is FAB, this is FAD. Okay, let us suppose this angle is given as 30 degree. Let us suppose this is given as 30 degree. Okay, so can we calculate the value of FAB and FAD? Yes, we can draw the free body diagram of joint A. Now in joint A, there are only two unknown forces, two equations we can create, we can easily solve, right? So we can say the total horizontal, let me draw the diagram. We are having this as joint, this is FAB, this is FAD, and this is 5 Newton, this is 30 degree. Okay, so we can take total horizontal force equal to 0, that is FAD plus FAB cos 30 equal to 0, and total vertical force equal to 0, that is 5 plus FAB sin 30 equal to 0. So by solving these two equations, we can easily calculate FAB and FAD very easily. Okay, FAB and FAD we can calculate, and this way you can calculate the forces in the remaining members. Now, can we directly take a joint B? Yes. Can we directly take the free body diagram at joint B? It's not possible because if you try to take, there are three unknown forces, two equations will be created, total horizontal force and vertical force. So three unknown forces, two equations, not possible to calculate. So that is the reason always you have to take only that joint, you have to start from that joint where only two unknown forces are there. Max to max two unknown forces. If you're having more than two unknown forces, you cannot take that joint, you have to take the adjacent joint where two unknown forces are there. Right? Okay. So here you can calculate FAB, you can calculate FBC very easily. Right? Now let us suppose you calculated and you got the value of FAD. Let us suppose you will be getting, I think, 30. What's the value you are getting? To track the ratio, this is tan 30, 5 root 3, I think. Yes? Sin 31. 5 root 3. FAB, sorry, FAB, you are getting 5, no, FAD, FAD, you are getting 5 root 3, yes. Let us suppose, okay, clear. FB, 5 root 3 by 2. And if you calculate FAB, you are getting minus 10 Newton. Let us suppose you are getting minus 10. Okay. Now, what is the meaning of this negative sign? Negative sign simply means that the nature of force is opposite. That means you have assumed tensile in nature, but in reality, the nature of force is not tensile, it is compressive in nature. So, I can say the force induced in the AB member is compressive in nature, and the force induced in the AD member is a tensile in nature, because we are getting a positive value. Okay, that is the reason initially I have told you, you assume all the force to be tensile and that to be positive. In any case, if you are getting any negative sign, that simply means the force in that member is a compressive in nature. Okay, fine. Is this clear? Now, let's talk about the method of section. What is method of section? Now, method of section is quite interesting. In method of section, what we have to do is we have to take a section which should be passing through 3 members. It's very important. Let us suppose I'm having a question like this. Okay. Let's say this is a roller hinge support, and this is the roller support. This is A, B, C, D, E. And they're asking you what is the force in the member FBE. Let us suppose there is some 100 Newton and 100 Newton applied over here. This is exactly symmetrical body. Okay. So, definitely over here we'll be having the reaction force we can easily calculate. Now, if they're asking you FBE, if we are using the method of joint, then you have to start from this point, then draw the free body diagram, get this value FAB and FAE, then you go either this point, okay. But if you take this point, BE, CE and ED is not given, so you will be taking this point, then you calculate the value of FBE. So, slightly lengthy process to calculate the force in the member BE. Instead of that, what you can do, you can go for the method of section. What is the method of section? You take a section in the solid which is passing through from that member in which you have to calculate, and it should not be cutting more than 3 members. Okay. So, if they are cutting, let's suppose you are taking a section like this. Now, it's your call, you can eliminate the left hand side and right hand side. But you always need to eliminate those sections where number of members are more. Try to eliminate those sections where the number of members are more, or you try to eliminate those sections if on the one side both the reaction forces are coming, you try to eliminate that. It will be easy for you for calculation. Let us suppose, because this is identical in nature, we will be eliminating the right hand side. So, we can say if you try to draw the left hand side, it will be something like this. It will be something like this. This is your member, this will be the half member, this will be the half member. This is RA, this is B, and always try to draw all the forces which is present. This is C, this is E. Now, if you want to calculate the force in the BE, can you tell me you can take moment about which point? If you want to calculate the force in the BE member, what you can do, you can calculate, let us suppose, you can take the moment about, or what you can do, you can take the total vertical force equal to 0. Yes, you can take the total vertical force equal to 0, because this RA is equal to 100 Newton. RA is equal to 100 Newton. If you take all the vertical force equal to 0, what will happen? This component, let's say this is theta, so this will be FBE sine theta in the downward direction, 100 Newton in the downward direction, plus 100 minus 100 Newton in the upward direction, okay, equal to 0. So, we are getting FBE is equal to 0. That's it. In 3 lines, we are able to get the final answer. FBE sine theta downward, 100 Newton downward, and RA upward, because there are only three forces acting in the vertical direction, RA 100 and a sine component of FBE. Problem solved, you are getting FBE is equal to 0. That means no force is being induced in the BE member. That is the reason we are calling this to be a zero force member. That is the reason we are calling this to be a zero force. If you are taking moment about point A, let us suppose, if you take moment about point A, then you will be creating a moment due to FBC, FBE, which is not possible because BC and BE both are not known. Okay. Let us suppose if you are taking a moment about point B. If you take moment about point B, make it equal to 0, then you will be able to calculate this force FAE. Then you will be calculating FAE very easily. If you take moment about point B, then you will be able to calculate the force in the A member. Is this clear? Understood? So this way you have to select the point according to what is being given in the question, what is being asked in the problem. Then that's way you are able to calculate. Let us suppose you want to calculate FBC. If you want to calculate FBC, can you tell me about which point you will be taking the moment? If you want to calculate the force in the member BC, you will be calculating moment about which point? Anyone? Now you have to forget this rest over. You only have to see this diagram. You only have to see this diagram. That's it. If you want to calculate the force in the BC member, then you will be taking the moment about which point? Definitely I'll be taking moment about point E. If you're taking moment about point E, AE and FBE will create a zero force member, and 100 Newton and 100 Newton we can easily calculate what is the moment about point E. है ना? Very good, Vinay. Very good, very good. Is this clear? Okay, this is the way by which you can able to calculate the different forces in the trusses by using method of joint. Method of joint is actually very easy, but if they're asking the member force in the member which is some interior part of the truss, go for method of section. If they're asking the member of the force you need to calculate in any member which is at the extreme point, let's say this one or this one, CD or AB or E or ED, go for the method of joint because you will be able to easily do the analysis. You can easily draw the free body diagram at the corner points. Okay. Right. Now, the second type of question that you can expect in the examination from the trusses topic is to find the zero force members. To find the zero force, how you can identify what is zero force member? We have already seen one example over here. The zero force member is basically that member where no force will be induced. Now, there are some short tricks or techniques from where you can identify the zero force member. Trick to identify zero force members. Okay, what is a trick to identify zero force member? Let us suppose in a complete truss, if you are having a joint, which comprises of three members, no external force is being applied. Okay, or there are three members or three forces acting. In this case, we can say, let us suppose this is F1, this is F2 and this is F3. Then we can surely say the force in the F3 member will be equal to 0. The force in the F1 member will be equal to 0. Why? If you try to take the total vertical force equal to 0, let's say this angle is theta. We can say F1 sine theta equal to 0. Theta cannot be equal to 0. We can say F1 equal to 0. So we can directly say that whenever in a three member structure, if there is any non-collinear force at a joint, if there are two collinear, then the third non-collinear force or third non-collinear member will always have a zero force. Always. Okay, that could be like this also. That could be at any angle also. It is not mandatory that it should be 90 or any at angle. It always will be having a zero force. Second way is you can identify, one more technique is you can say, one second. you can have some extended members. What is extended members? Let us suppose I'm having a diagram like this. I'm having a diagram like this, and the force is being applied over here. Let's say 100 Newton. Let's say this is A, B, C, and D. They're asking you what is the force in the CD member. What is the force in the CD member? How we can calculate? Very easy. FCD, how we can calculate? Now, if you see, if you try to take the free body diagram at point D, so at point D, there is FBD and FCD. That's it. No other force. You take the vertical force equal to 0, we can simply say FCD is equal to 0. If FCD equal to 0, then FBD equal. So this both are a zero force member. No force will be induced. So if we are having some extended member and no external force is being applied directly, we can say that that member is a zero force member. Okay. So let us take this example. Can you tell me how many members will be a zero force member? And you have to check each and every member, then come to the final conclusion. Do not directly give the answer. Try to check each and every member, then only come to the conclusion. Can you tell me how many members will be the zero force member? Total, you can tell me the number. Out of 1, 2, 3, 4, 5, 6, 7, 8, 9, how many members are zero force member? Quickly. Okay. Anyone? Now, if you see, joint F is an extended member. So here we can say these two are directly the zero force member. These two are the directly zero force member. Right? Now, if you take joint C, we are having this as FCB, this as FCA, and this as FCE. Right? You can say FCB is a zero force member because this is the third non-collinear member. So this is a zero force member. Directly we can say. Yes. 5. Okay. Anyone else? Vansh and Shreyas is saying 5. What about the other students? As in the entire structure, there is no horizontal force. So at RA also you will be having only one reaction. This is, let's say, RA and this is RE. Right? And let's say all the dimensions are same. This is L, this is L, and this is L. Okay. Quickly. P1 and P2 is being given, or let's say this is P and P. Let's say this is P and P to make it more easier for you guys to calculate. What's the value of RA? What's the value of RE? Right? Now, can we say BD is a zero force member? Yes. If you try to take point D, if you try to take joint D, we are having one P, right? And here not need to draw, right? So this is your E and this is FDB. So can we say this is a zero force member? So this is also a zero force member, right? BD is also a zero force member. Okay. Now we have to calculate RA and RE. Now if you take the total vertical force equal to 0, so RA plus RE is equal to 2P. Right? Now if you take moment about point E, can we say RA is equal to, if you take moment about point E is equal to 0, that simply means P and RE will create zero moment. So P into L and RA into 2L. P into L is equal to RA into 2L. So RA is equal to P by 2. RA is equal to P by 2. Place it over here. This is equal to P by 2. RE is equal to, this will be 3 by 2. 3P by 2. Okay. So we are getting RE and RA the value, right? RE and RA value we have already got. Okay. Fine. right? Now, because this is a non-zero force member, so we can say this is also a non-zero, this is also non-zero. You can cross check, you can calculate, these two are non-zero. Now if you try to take it over here, we're having this is a non-zero, this is also non-zero, right? BE member, now if I want to check BE member, because rest all the members we have checked, we can take either this one like this. We can take the section, we can eliminate the right hand side. Let us suppose I am taking the section and eliminating the right hand side. Okay, I am taking the section and eliminating the right hand side, so it will be something like this. DE, this one, this is E, this is C, this is P by 2, right? And that's it, and there is we're having B. Okay, this is B point. Now if you want to take if you want to calculate what is the force in the member B, you take the total vertical force equal to 0, right? If you take vertical force equal to 0, let's say this angle is theta, we can say FBE sine theta in the downward direction plus P minus P by 2 equal to 0. So FBE is equal to minus P by 2 sine theta. Okay, clear? So BE is non-zero force member. It is definitely we can say it's non-zero force member, right? It is not a zero force member, it is a non-zero force member. The reason being RA and B RA and P are not equal. This force are not equal, so definitely this is a non-zero. So in total we can say there are 4 members which is having the zero force member. There are in total 4 members which is having a zero force member. Is this clear? Understood? Okay, done? Clear? Eh? Done, everyone? Clear? So this is the complete understanding of the trusses topics. Any doubt you were having, please do let me know. Now we will be entering into the dynamics part. Okay. Let me take one more question, because trusses is the last topic for civil students. Let's take one more problem so that you are able to identify very easily. Let us suppose I'm having a complicated diagram like this, and you try to tell me how many zero force member are there. Okay. Something like this, and this is a roller support, and this is a hinge support, right? So A, and we are having a 10 Newton force acting. This is B, this is C, this is D, this is E, this is F, H, I. Okay, tell me number of zero force member. This is exactly acting at the center point. It is exactly acting at the center line. Quickly, how many members are the zero force member? You have to tell me. Let me make it more complicated. J, K. Tell me. How many members are the zero force members? Is there any camera problem? All good? Okay. Count the number of zero force member very easily. Whenever you're having these kind of questions, now you try to identify the joints where 3 members are there. 6. Rahul is getting 6. Perfect. What about the other students? 4 plus 2, 6. Okay, fine. Let's start with joint H. If you take joint H, then you can see that HB and HJ are collinear. So HI is a zero force member. Similarly, if you take joint G, GB and GK are collinear. So GF is a zero force member. Perfect. Now, once you are identified one zero force member, you can eliminate from the calculation. Now, if you take joint J, right, JH and AJ are collinear. So JI is a zero force member. Same goes with here, FK is a zero force member. Right? Perfect. Because this is symmetrical, we can say this is equal to 5 Newton and this is also equal to 5 Newton. Okay. Now, if you take point D, DI is a non-collinear, DA and DE is a collinear. So DI is a zero force member. Same goes over here. EF is a zero force member. Right? If you take BI, DI is exactly equal to BI, DI is already 0, BI is also 0. Same goes with FB, is also 0. Right? Okay. Now, let us cross check other points. Because we are having some angle, so this is a non-zero, this is also a non-zero. Same goes over here, this is non-zero, this is non-zero. So CK is non-zero, GK is non-zero, GB is non-zero. Same goes over here, AJ non-zero, JH non-zero, HB non-zero. So we have cross-check and AD is equal to DE. That's it. So in total, we are having 8 members as zero force. 8 members as a zero force. Okay. We are having in total 8 members as a zero force. Is this clear? 6 is not the correct answer. 8 is a correct answer. Done? Clear? Okay. Okay, perfect. So now let's try to proceed to the dynamics part. Right, for civil students already we have completed. Now we can continue with the mechanics part. We are having dynamics left out. We are having some applications of frictions. We are having the Lagranges also being left out. Okay, so let's start with the dynamics part. Dynamics is basically, now we are starting from the mechanics. So I tried initially will be taking mechanical and civil both, so that both will be benefited. Right, so after that, now let's proceed with the mechanical portion. Right. Okay, clear? So now dynamics means the body is in motion. Dynamics means the body is in motion, right? The body is in motion, right? So here we have already seen that dynamics is classified into 2 categories. We are having kinematics and kinetics. Right? Okay, now kinematics means already we have seen the force is not being considered, and in kinetics force is being considered. And what is the force? Force is equal to mass into acceleration, where force is considered as a cause and acceleration considered as its effect, and mass is nothing but resistance to any change, which we call it as inertia. Okay, which we call it as inertia. Now, if I talk about kinematics, because we are not considering mass, so here we are basically calculating what? We are calculating acceleration, we are calculating velocity, we are calculating displacement, we are calculating angular velocity, we are calculating the angular acceleration, we are calculating the theta, like this. I'm taking both a linear or translation and the rotational motion combinedly in one go, so that we can have a better understanding. In kinetics, what we do, we try to take the total force is equal to mass into acceleration. We try to take this formulation and try to create a relation between the unknown parameters and get the value. Okay, fine. Chalo. So now let's talk about the first one. That is the motion under uniform acceleration. Uniform acceleration means the acceleration is constant. The acceleration is constant. So if I take acceleration to be constant, can we say if I take linear motion, then we can have three equations of motion, that is v is equal to u plus at, where v is final velocity, u is initial velocity, t is the time period, s equal to ut plus half at square. I'm not taking the derivations, not at all required. V square is equal to u square plus 2 into a into s. If you take the rotational motion, then omega is equal to omega naught plus alpha into t. Theta is equal to omega naught t plus half into alpha into t square. Omega square is equal to omega naught square plus 2 into alpha into theta, right? 2 into alpha into theta. Okay, and we know that what is acceleration? That is the rate of change of velocity with respect to time. What is velocity? That is the rate of change of displacement with respect to time. Because in kinematics, we try to calculate the effect directly. We are not considering the mass, so force is not being considered. Okay, fine. It's something like this. We are having a body, we are throwing a body, that's it. Now the body is moving. What will be the acceleration, velocity and displacement? That we are basically calculating. Okay, now if the body is moving under the force of gravity, then how you can create the equations? Now let us suppose there is a body which is moving downward with an acceleration of g, right? So here also we can simply say all the equations that we have discussed over here, instead of a will be using g, that's it. Okay, if you are moving against the gravity, then we'll be using minus g. If you're going in the force of gravity, then we will be going with a is equal to g. Directly we will be taking it as positive. Okay, fine. But the question is, if you are having the motion under variable acceleration, let us suppose acceleration is a function of time. Let us suppose we are having this condition. It's a variable term, it's not constant. In the previous case, the acceleration was constant. Now, if I try to plot a graph between, acceleration versus time, yes, can you tell me what will be, or let's say I'm taking one as acceleration versus time. What will be the area under this curve? What it will be resembling? Anyone? What is the area under acceleration versus time? Anyone? Anyone who can tell me, if I say this move, we are having from point 1 to point 2. I think there's some. I think there is one issue. Yes, I think now it's okay. Video, are you able to see? Momentum. Yes, anyone? Yes. Okay, chalo. Momentum, no. We know that A is equal to dv by dt. A is equal to dv by dt, right? So A dt is equal to dv. Integrate both the side. What is a dt? This is a dt only. That is nothing but velocity, the change in velocity. The area under the acceleration versus time will be giving you the velocity, right? Okay, understood? If I'm having one relation as v dt, velocity versus time, if you're having one graph, the area under v dt, what will be this? V is equal to dx by dt. So v dt is equal to dx. Integrate this, that will be equal to x. So this will be giving you the area under this curve will be giving you displacement. Okay, is this clear? Understood? 1 marks question you can expect from this segment. 1 marks question you can expect, right? Okay, let us suppose if you are having acceleration as a function of let's suppose displacement, function of x, then a is equal to dv by dt, a is equal to dv by dt, or let us suppose velocity is a function of displacement. Then they are asking you what is the acceleration. So a is equal to dv by dt, but v is a function of x, so we can say this is dv by dx into dx by dt. Dx by dt is v, so we can say v dv by dx will be giving you a. So this way we can calculate the value of acceleration. Okay, we can calculate the value of acceleration if they are giving you some equations like say v is equal to 2x square plus 3. What is the value of a? Something like this. If they are giving, then you can easily calculate the value of acceleration just by differentiating with respect to this one. Okay, fine. Right, now the important part where you can expect question is from the rolling motion or general plane motion. Okay, what is rolling motion? Let us suppose I'm having a roller, right? Now it is undergoing a rolling as well as a translatory motion. Then what, first of all tell me what is the criteria for pure rolling condition? Anyone? What is the condition for pure rolling? Pure rolling. Anyone? What is the condition or criteria for pure rolling? This is your center. Let's say this is O. Exactly. For pure rolling, that is no slip condition. No slip condition, right? No slip condition means at the point of contact, the velocity must be equal to 0. The velocity must be equal to 0. Let us suppose I am taking multiple points. I am taking point P over here, I am taking point A over here, I am taking point B over here. Okay. If you take point B, will be having one velocity as r into omega and one v over here. We'll be having one v velocity when r into omega as the velocity, but at this point we'll be having one r omega and v. So for we know that at the point of contact the velocity must be equal to 0. That simply means v is equal to r omega. That's the reason at point P the velocity equal to 0. Okay, the velocity will be equal to 0. So this is the condition for pure rolling or the no slip condition. The velocity at the point of contact will be equal to 0. Now if I want to calculate what is the total velocity at point B, that is equal to, we'll be having one v velocity, will be having one r omega, so that is equal to 2r into omega. This is the velocity at point B, right? If I want to calculate what is the velocity at point A, that is equal to one v in the I cap direction, one v in the r omega in the j cap direction, right? So we can say the velocity v vector magnitude will be equal to under root of 2 vector, same vector, so we can say under root of 2 r into omega. Okay, so this way we can calculate velocity at any point. We can calculate velocity at any point. But let us try to understand the pure rolling condition from one more perspective, that is from the instantaneous center of rotation. I hope so you know, because theory of machine marathon is being done, so you know about I center. Can you tell me where will be the instantaneous center of rotation for a pure rolling motion? Where will be the instantaneous center of rotation for a pure rolling motion? Anyone? Can we say whenever a body is undergoing pure rolling motion, at the point of contact, you will be having the I center. That means our entire body will be considered as a pure rotation about the I center. Let's say this is rotating with a velocity of omega. If I want to calculate what is the velocity at this point, let's say this is point taken as A, B or C. Let me check B. So what we can do, we can measure distance B, right? So velocity at point B is equal to the distance Bi into omega. What is the distance Bi? That is nothing but the diameter, that is 2r into omega, and are we not getting 2r omega as the velocity at the point B? If I want to calculate what's the velocity at point, let's say this is A, okay. So what you do, you try to measure distance A. So velocity at point A is equal to the distance Ai into omega. So what will be this distance Ai? Anyone? This is the center, this is your radius r, this is radius r. So can we say this is root 2r? So this is root 2r into omega, and are we not getting the same velocity, that is root 2r into omega at point A? So easily we can calculate velocity at different points only just by knowing the I center. That way we are able to analyze the pure rolling condition very easily. Okay, that way we are able to analyze the pure rolling condition very easily. Is this clear? Understood? Clear? Chalo, one more question, let me ask you. Let us suppose a body is moving with constant velocity, linear velocity, in a translatory direction. Can you tell me what will be the acceleration at this point? What will the acceleration of this body? The body is moving in a constant linear velocity in this direction. So tell me what will be the acceleration, A value? 0? Yes, sir, it is rate of change of velocity. Velocity is not changing, so A value is equal to 0. No doubt in this. No doubt in this, right? But let us suppose I am taking one more example. There is a body which is rotating in a circular path and having a constant omega. Omega is constant. Can you tell me what is the value of acceleration? 0 or non-zero? This is radius r. Okay, omega is the angular velocity. What is the linear acceleration, 0 or non-zero? Omega is constant. Omega is constant. Omega is constant means V is equal to R omega, that is also constant. Now tell me whether the linear acceleration will be 0 or non-zero. Yes, very good Vinay, Abhi, Shreyas, absolutely correct. It will be non-zero. Sir, how it is possible? We are having velocity is equal to R into omega. R is not changing, omega is not changing, then how the acceleration is non-zero? Yes, anyone? Now tell me the reason also why it is non-zero. Why it is non-zero? Tell me. It's very interesting. From there you can expect one question. Then we'll be starting with the kinetics part, and kinetics, very interesting topics will be taking into consideration. Yes, everyone. Why we are getting acceleration even though V is equal to R omega? Okay, centripetal acceleration, I've agreed with that, but tell me the reason. Very good, Abhi. Velocity is a vector quantity. Okay, its magnitude is not changing, but can we say its direction is keep on changing? Because of the change in direction, there is one acceleration coming into picture. That acceleration we call it as radial acceleration. That acceleration we call it as radial, and it is always toward the center, right? So acceleration is equal to dv by dt, right? Because of magnitude there is no change, but because of the change in direction there is one acceleration present, that is called as radial acceleration. So we can say over here we'll be having two basic approaches. Due to the change in direction, of velocity, we are having a radial acceleration, right? And due to the change in magnitude, we'll be taking one example also, we are getting one acceleration we call as tangential acceleration. Is this clear? Okay, right? And what's the direction? Direction will be like this. Okay, this will be the direction of the radial acceleration towards the center. This will be the direction of the acceleration, and that acceleration. And if you try to, let us suppose having a mass m, if you try to multiply this AR, we'll be getting one acceleration we call as centripetal acceleration. If you try to multiply, Fc is equal to m into AR, AR is equal to R into omega, okay, R omega square. R omega square. So Fc is equal to this. So the radial acceleration is equal to R omega square. Okay, due to the change in the direction of the velocity, we are getting this one, that is R omega square. And what is tangential acceleration? Tangential acceleration is equal to R into alpha. Here alpha is equal to 0. Alpha will be tending to 0. Why? Because omega is constant. Alpha is equal to rate of change of angular velocity with respect to time. If omega is constant, then definitely alpha will be 0, and that is the reason here it will be 0 in our case. In this particular example, it will be 0. Okay, but let us suppose if you are having a condition like this, a body which is rotating in a circular direction with some angular velocity of omega, right? Omega is not constant. If omega is not constant, then alpha is not equal to 0, right? If alpha is not equal to 0, then we'll be having one radial acceleration that is equal to R omega square, and the length will be towards center, and AT is equal to R into alpha, tangential direction along alpha. That means if I say, if you're having this as the alpha, right, then this will be your AT and this direction will be your AR. Is this clear? And if I want to calculate what is the total acceleration, is equal to under root of AR square plus AT square, because both are perpendicular to each other. So we can easily calculate the total acceleration at any point by using this simple formulation. Understood? By using this simple formulation, we can easily calculate what's the total acceleration of this. Yes? Okay. Perfect. Done. Kinematics part clear. You have taken rotation, linear and general motion collectively in one go. Okay. Now let's talk about the kinetics part. Kinetics parts, in this case, the force now will be considered. The force will be taken into consideration. So we can say now the force will be taken into consideration. If force is not equal to 0, then total force is equal to mass into acceleration. Now we can create equations to calculate the value of A or any other force just by using this relation. That means if I'm able to calculate, let us suppose there is a body, there are multiple forces acting. So there are multiple forces acting, and if I try to calculate what's the net force acting on the body, right? And if I try to calculate, say, in the horizontal direction, what is the net force, then we'll be able to calculate what's the total acceleration in the x direction. Okay. Similarly, if I want to calculate what's the total force in the y direction, we'll be able to get the total acceleration in the y direction. Clear? Now the mass will also be taken into consideration. Okay, and this is nothing but Newton's second law. If let us suppose you are having a body, let us suppose there's a body which is hinged at this point, let us suppose, and you are applying a torque, then net torque acting on this body will be equal to I into alpha. I is the moment of inertia about the hinge point where you are calculating into angular acceleration of the body. So this way, this is Newton's second law in the rotational perspective, in circular motion rotation perspective. Okay, let us take one example and then we'll be talking about the D'Alembert's, or let us do one thing, let us take an example of a D'Alembert's principle, then we'll be taking examples of linear also and circular also collectively, then we'll be going for the next segment. Okay, fine, let us talk about the D'Alembert's principle, but in short, let me help you out. You always use Newton's second law. The reason being why I'm saying that, because it's just very easy to calculate the total force or the total torque acting on the body, and that you have to equate to mass into acceleration. But if I talk about D'Alembert's principle, that is also very easy. Let us suppose we are having a body, and let us suppose the total force acting on the body is F. This is the total force acting on the body, right? Now what D'Alembert suggested that if I want to make this body to be in the equilibrium condition, then I have to apply an opposite force which is equal to mass into acceleration. Then can I say the body will be in equilibrium? Because we know that net force acting on the body is equal to mass into acceleration, and this force he is considered as the inertia force. Okay, and he stated that the total net force acting plus the inertia force must always be equal to 0. So same thing which Newton's second law suggested, same thing he is now introducing, but in a slightly different form. One problem students will be facing in D'Alembert's principle is the direction of A. Here the direction of A will be opposite to that of the actual direction. So at the end you have to make sure at the end you have to take the opposite value or opposite direction of A. Okay, so in order to eliminate that confusion, you try to use the Newton's second law. You calculate the total force acting on a body. Let's say this is the total force acting on the body, right? And that is equal to mass into acceleration. That's it. Problem solved. Problem solved. Okay, clear? Let us take some examples of linear motion. Then we'll be taking the example of circular motion. The first example, that a very common example from the linear motion is the motion of a lift. Okay, let us suppose a lift is moving upwards. There's a lift, there will be a tension T, the total weight of the lift W. Now if the lift is moving upward, right, then tell me what equation we can create. What's the net force acting on a body? Can you tell me what's the net force acting on a body? Because the body is moving upward, that means the tensile force is more than that of the tension in the rope will be more than that of the weight. We can say T minus W will be the net force. And that according to Newton's second law, the net force will be equal to mass into acceleration. Or I can say T minus W is equal to W by G into A. I hope so you have seen, or I've seen why we have written W by G, because W is the weight of the body. Okay, we have to write mass into acceleration. That's the reason I've divided by G, right? Okay, let us suppose the lift is moving downwards. When the lift is moving downwards, so weight is more than that of the tension in the rope. That is the reason the body is moving downward. So net force acting on the body will be equal to W minus T, and that is equal to W by G into A. Okay, so this way I am able to create the relation between the unknown forces, unknown parameter, and will be able to calculate the whatever they are asking. If they're asking the tension in the rope, if they're asking the acceleration in the lift, easily we are able to calculate. Okay, clear? If this is clear, tell me what will be the equation for this one. It is a frictionless pulley. and M2 is greater than that of M1. Quickly, what will be the equations that will be created? What will be the equations that will be created? Now, because the same string is being connected, so definitely both will be having the same acceleration. M2 is having more mass, so it will be moving downward with some acceleration A. M1 will be moving upward with an acceleration of A. Okay, so because same string, so the tension will be same throughout the body. This is T, this is T. So if we try to draw the free body diagram of mass M1, we are having M1G downward, tension T upward and A upward. So exactly similar equation we will be getting as of that the previous one. So here the tension is more than that of weight. That is the reason the mass M1 is moving upward. So we can say T minus M1G is equal to M1A. Right. If I try to draw the free body diagram of M2, right? So we are having this as T, this is M2G, this is A. So we can say M2G minus T is equal to M2A. So two equations, two unknowns will be there. Easily we can calculate the A and tension T. A and tension T we can easily calculate. Right? Now let's try to complicate the motion of the connected bodies. Okay, is this clear? Then we'll be going for that inclined path. Keep 1 second. Let me copy this. Let's try to have some blank slides so as to discuss it very easily. Okay. Yeah. So now let us suppose we are having one pulley like this. Okay. Tell me. First of all, tell me, will the acceleration of mass M1 and M2 will be same or unequal? If it is unequal, then what's the relation between A1 and A2? Quickly. Let us suppose if M2 is moving downward with some acceleration of A, then what will be the acceleration of M1? Will it be having same A, or do we have A by 2, or do we have twice of A? Quickly tell me the final answer. What will be the relation between acceleration of mass M1 and M2? Quickly. Quickly. Now, if you try to visualize, we in the two masses, the strings are not same. We are having a different string, right? Let us suppose if you are having tension T over here, we'll be having tension T over here, but here we'll be having tension of 2T, twice of T, right? Okay, now tell me, okay, do we have same acceleration? Now let us try to visualize. If this pulley is present over here, if it is moving from this point to this point, okay, that means M2 is having some displacement of x. M2 is moving with the displacement of x, right? Okay, fine. So when this is moving downward, as on the right hand side, the pulley is being fixed, the string is being fixed. So cannot, it is an inextensible pulley, inextensible string, right? So what will happen if this is moving downward? So we need to have x and x deflection over here because this is being fixed. So we will be having on this string, let me draw the complete diagram. Now, because this side is being fixed, we'll be having x over here, so we'll be having 2x over here. If this is 2x, it will be moving upward with the 2x deflection. Now, if this is x, it will be v, it will be a. This 2x, this is 2v, this is 2a. That means m1 will be moving upward with an acceleration of twice of a. m1 will be moving upward with an acceleration of twice of a. Now we can create the equation, the free body diagram of m1. This is m1g, this is t, and this is 2a. So we can write t minus m1g is equal to m1 into 2a, right? If I try to draw the free body diagram of m2, this is m2g, this is 2t, and downward is a. So we can write m2g minus 2t is equal to m2a. So two equations, two unknowns, easily we can calculate the given parameters. Easily we can calculate the given parameters. Is this clear? I'll be taking one more connected pulleys so that your confusion will be eliminated, because it is being fixed, right? So we won't be having any motion on this side. So if this is x motion, so x and x should be moving on both the side, but because this is fixed, we'll be having 2x motion on this side. So this is 2x, the same is being connected over the m1 pulley, right? Now, if I take one more example like this, this is m1, this is m2, this is m3. Okay, fine. So there is a string, right? So I can say that if this m2 is moving downward, m2 is moving downward with an displacement of x, then on this side and this side will be having x and x. So same upward will be x and same upward will be x. That means we'll be having a, will be having a, will be having a. So I can say, if I try to draw the free body diagram of m1, this is m1, this is t, this is a, right? If I try to draw the free body diagram of m2, we're having m2g, we are having this is t, this is t, this is m3g, t, and a. So we can write the equations, total force acting on a body, and create the equations and get the value of a. Clear? Understood? The connected pulleys in the linear motion, then we'll be talking about the circular motion. Okay, clear everyone? Any doubt in this? Please do have a look, and if you have any doubt, you can do cross verify. All clear? Chalo, very good Vinay, very good. Now let's talk about some if I try to include the friction also, then what downward with some acceleration a, this is moving with some acceleration of a. So if I try to draw the free body diagram of m2, right? So this will be m2 g, this will be t, and this is moving upward a. So t minus m2g is equal to m2a. That's it. Second, if I try to the free body diagram, right, we'll be having this as, let me draw it like this. This is the normal reaction. This is m1g. So this is m1g cos theta. Let us suppose this angle is theta. This is m1g sin theta. And this is friction, right? So I can say, because the body is moving downward, so m1g sin theta minus f is equal to m1. One more tension T is there. Minus T is equal to m1a. That's it. Only difference now will be there is we'll be including the friction also. Only difference that will be coming is the friction. And what is n? N is equal to m1g cos theta. So f is equal to mu into n, you can place it over here and get the value of A and D very easily. Okay, right? Is this clear? Second half. Done. All right. Now let us talk about the circular motion. Let us suppose I am having a rod, okay, having a mass, a weight W. This is weight W, right? And it is released from rest. Released from rest. So can you tell me what will be the reaction force at point A? What will be the reaction force at A? Yes, it is having length L. It is having length L, weight W, or mass M. Let us take it as mass M. That will be much more easier for you guys. Chaliye. What will be the reaction? Now, if this rod is released from rest, can you tell me what will be the angular velocity at this moment? What will be the angular velocity at this moment? Anyone? Omega value. It will be equal to 0 because it is released from rest. So definitely whenever a body is released from rest, initial velocity equal to 0, omega equal to 0. Only we will be having alpha. Alpha will be present. And which is the driving force? Weight is the driving force passing through the CG. Okay. So can we say this is point, let us suppose C. Can we say at point C, we will be only having one acceleration? Can you name that? At point C, we will be having only one acceleration. Can you name that acceleration? Because omega equal to 0, omega equal to 0, so radial acceleration is equal to 0 since omega equal to 0. But because alpha is present, we need to calculate alpha also. Alpha is present, due to that tangential acceleration will be present. Yes. Can you tell me what will be the direction of tangential acceleration? What will be the direction of tangential acceleration? Very good, Ajay, Vinay, very good. Definitely in the downward direction because that is the driving force. So I can say the body is trying to move downward. So this is the tangential acceleration. And what is tangential? That is equal to r into alpha. What is radius? That is L by 2 into alpha. So this is 80. Perfect. We got one relation. Now at point A, this is the hinge point. We'll be having two reactions. This is RAX and this is, let us suppose, RAY. Okay. Now because here AR is equal to 0, so can we say RAX is also equal to 0? So direction would be towards as, but sense is downward. Direction means I'm talking about sense of rotation. Definitely clockwise, anti-clockwise is that. Definitely. Direction simply means the right hand thumb rule inside the board. Okay. Fine. Sense of rotation. Clear, Ajay? Correct. But if I talk about AT is a linear velocity, so direction will be downward. A linear portion, we will be using the direction. In circular part only we can say alpha direction is inside the board, but AT direction is downward. That we can say surely, because that is a linear acceleration. That is not angular acceleration. Okay, so AX is directly equal to 0. Now we only calculate what is the value of A. Now we can take the total vertical force. What is the total vertical force? Right? Total vertical force is equal to mg is acting downward, ray is acting upward. Perfect. And we know that total force is equal to mass into acceleration. So mg minus ray is equal to m into at. Equation number 1. Yes. Okay. Right. Now, if I want to calculate the moment about point A, what is the moment about point A? Anyone? What is the moment about point A? That is equal to mg into L by 2. Moment about point A is nothing but mg into L by 2, and we know that this is a total moment, not 0, mg into L by 2. Okay, and we know that according to Newton's second law, the total moment about point A will be equal to the moment of inertia about point A into alpha, right? Perfect. So we can say mg, or total moment about point A, is equal to mg into L by 2 is equal to Ia into alpha. Now if we are having a rod, it is hinged at this point, having mass m and length L. Can you tell me what is the moment of inertia of the rod? What is the mass moment of inertia of the rod about one of the ends? From the CG, ml square by 12 is from the CG. You can use the parallelogram law, theorem of parallelogram, or parallelogram axis theorem. We can calculate easily what is the moment of inertia about point A. ml square by 12 plus m into L by 2 whole square, that is coming out to be ml square by 3. So we can place it over here. mg L by 2 is equal to ml square by 3 into alpha. M get cancelled out, 1 L get cancelled out. Okay, so we are getting 3 by 2g is equal to L into alpha. And what was AT? AT was equal to L by 2 into alpha. Remember, AT was equal to L by 2 into alpha. Let us try to multiply 2 on both the sides. So we can say AT is equal to 3 by 4 into g. Once you are getting the value of AT, place it over here. We can get the value of RAY, because that will be mg minus RAY is equal to m into 3 by 4g. You solve it, you will be getting the value of RAY, and that was a question asked for 2 marks in the GATE examination. Okay, now you can easily calculate the total reaction at point A. Clear? Only difference that we are observing is, now instead of only rotation, only linear, we are taking the help of rotation as well as a linear. But the concept is still the same. There is no change in the concept. Okay, clear? There is no change in the concept. Fine. Chalo, quickly, let's try to proceed forward. Okay, chaliye. So now let's talk about one very important statement about momentum, right? We'll be talking about this momentum. But before that, I want to discuss very important 2 statements. Okay, what is the rate of change of linear momentum? Anyone? Of change of linear momentum. Anyone? Already we have discussed in the starting of the session. The rate of change of linear momentum, let us calculate d by dt of m into v. That is m into dv by dt. That is m into a, and that is nothing but our force. That is nothing but our force, right? But what is the rate of change of angular momentum? Of angular momentum. Anyone? That is d by dt of I into alpha. I into d alpha by dt. What is d alpha by dt? Oh, sorry, omega. So this is I into alpha, that is equal to torque. That is equal to torque. Simple one-liner questions you can expect from these statement based over the rate of change of this. Okay. Now let us talk about the concept of momentum. Momentum, normally we can, if I say linear momentum, we always say this is nothing but the product of mass into velocity. What is actually the meaning of this? Anyone? What do you mean by this word momentum? If I say the body's momentum is more, what do you mean by this? Can we say if the body's momentum is more, it will possess a high amount of energy? है ना? If the body is possessing high amount of energy, that simply means it will be able to move very far in a very small amount of time, right? If I'm able to calculate what is the rate of change of linear momentum, that simply we are getting the concept of force. Okay, so here we can say if you are having a car having 15 kg, if it is not at all moving, it will not have any momentum. But if you are increasing the velocity, definitely its momentum is going to increase. That simply means the force in order, let us suppose if it is moving with 20 kilometer or 20 meter per second, and if you want to stop that particular body, the body's force will be very much high force will be required. Why? Because already we have seen the force is nothing but the rate of change of linear momentum. The rate of change of linear momentum. Okay. If the momentum is having a larger change, then definitely we can say the force requirement will be very high, right? If a body is possessing a higher momentum, it will be required a high amount of force in order to make that body to be in the rest condition, in a very simplest way. Okay, fine. Right, now if I try to say momentum is classified under two categories. Momentum is classified, let me write it over here. Momentum is classified under two categories. We are having linear momentum and we are having an angular momentum. Okay, linear momentum and we are having angular, right? So what's the difference between linear and angular? Let us try to understand. Linear momentum, just now we have seen, that is equal to denoted as P, that is equal to mass into velocity. What is angular momentum? It is denoted as L. So angular momentum is equal to, it is a moment of linear momentum. It is a moment of linear momentum. That means it is equal to m into v into r, mvr, or we can say m into r into omega into r, or mr square omega. Okay, or that is I into omega. That is your, so I can say angular, okay, moment of linear momentum. I think there's some issues coming in the camera. Chalo, theek hai? Right. Now, what is work done? What is work done? Anyone? What do you mean by this word work done? Now we are about to have 40 minutes more. We'll be able to wind up the session. Okay, 40-45 minutes max to max. What do my work done? Yes. And whether it's a scalar quantity or a vector quantity, tell me, scalar or vector? What is work done? It is nothing but the dot product of force. It's a scalar product. Very good. F dot S, F dot S, right? Let us suppose if you are having, or we can say this is F into S into cos theta, Fs cos theta basically. Acha, what is the cross product of displacement versus force? What is the cross product of displacement versus force? What do we call that? The cross product of displacement versus force, that is we call as moment. R cross F, R cross F, that is moment. That's a vector quantity. The dot product of force versus displacement, it's a scalar quantity, right? Okay, now let us suppose I'm having a body and you are applying a force in this direction, and due to this force a body is moved by some displacement x in the horizontal direction. So we can say work done will be equal to F into x into cos theta. Either we can write it like this, or we can resolve the force F cos theta and F sin theta. Now F sin theta is creating a 90 degree, so it will be creating a 0 work done. The work done will be only due to the horizontal component because the displacement is in the horizontal direction. So we can say work done is equal to F cos theta into X. Both way we are getting the same result. Both way we are getting the same results. Okay, right? Is this clear? Now, once you have understood work done, we have to understand what is energy. What is energy? Anyone? Very basic question. Capacity to do work. If you are possessing energy, then only you will be able to convert into work done. Just like you might have studied in thermodynamics, one form of energy will be converting into another form, right? So energy also, if a body is possessing energy, definitely due to the change in energy, the work done you can either extract or you can provide the work, okay, or you can increase the energy by providing the work done. Like in thermodynamics, you have said that if you're providing heat to the system, its internal energy is increasing because its temperature is rising, so its internal energy is going to increase. So it is nothing but capacity to do work. If you're having energy, definitely you will be having capacity to do work. If you are taking food, you will be having energy, and due to that only you will be able to solve lot many problems, and easily you will be able to understand the concept. Okay, so here we can say energy can be classified into two categories. We are having kinetic and second is potential. Kinetic and potential. Kinetic is further classified into two categories. We are having a linear and second is, or translation, or second is the rotational. So linear is half mv square, rotation is half I omega square. Potential energy is due to the position of the body. I'm not taking the definitions because it is already, you know about what is kinetic, what is potential, what is linear, what is rotation, right? Now, let us suppose you want to calculate what is the kinetic energy of a rolling motion, because rolling is comprises of both the kinetic as well as the linear as well as the rotation. So it will be the combination of both. Okay, it will be the combination of both. Half mv square plus half I omega square. Okay, and we know that one very important work energy principle. What is work energy principle? Work energy principle. It states that work done is equal to the change in kinetic energy. Work done is equal to the change in kinetic energy. This is your work energy principle, right? And basically we have studied about Newton's second law. In that, what we are doing, we are using the Newton's second law in order to create the equation between the two unknown parameters and get the value of A or tension T, whatever you are getting. Work energy principle is also one of the way to calculate or to solve the question from the kinetics part, right? How we can calculate? Now let us suppose there is a body, right, which is moving from point 1 to point 2, right? Point 1 to point 2. Let's say this is the displacement x, right? Initially it is having some velocity v1, it is having some velocity v2. So let us suppose if we want to say how much force is required to move this body from point 1 to point 2. If you are taking the help of the previous one, you will be calculating the acceleration because displacement is given. So you'll be using v2 square is equal to v1 square plus 2 into a into s. From there you can get the value of a. Once you get the value of a, you can use it and get the value of force. But let us suppose if mass is not given, okay, and mass should be given, it's a slightly tedious task. So here you can directly say, let us suppose a force F is required to move this body from point 1 to point 2. So we can say F into x is equal to change in kinetic energy, that is half into m into v2 square minus half into m into v1 square. So in only one equation we are able to calculate the force F easily. If you are using the previous one, you will be calculating first of all A by using the third equation. Then once you are getting the value of F, then you will be calculating F is equal to m into A. From this way you will be able to calculate. But you can use this approach also to get the value of acceleration or to get the value of force required just by using this work energy principle, that is work done is equal to change in kinetic energy, that is the final kinetic energy minus the initial kinetic energy. Okay, clear? That is KE2 minus KE1. Sometimes it is beneficial, but I would again repeat, majority of the question will be solved by using the Newton's second law. That is the best way to solve the questions, right? Okay, now let us talk about the collision of elastic bodies. Now, what is the meaning of collision? Collision means impact. Collision means impact. Achha, what is the meaning of this word elastic? What's the meaning of this word elastic? Anyone? What is the meaning of this word elastic? Elastic means, let us suppose if two bodies are colliding. Okay, if two bodies are colliding, right? So after the collision, the second body or the body will be able to regain back its original shape. If a body is having the capability or ability to regain back to its original shape, there is no deformation left inside the body, that kind of body we call it as elastic bodies. Okay, fine. When two bodies are colliding and they're moving apart, so there is a possibility that there's some deformation left out inside the body. That kind of bodies we call it as non-elastic or plastic bodies. But if the body is able to regain back to its original shape, there is no deformation left out inside, not even 0.1% is being left out, that kind of body we call it as the elastic bodies. Okay, that means it is having the ability to regain back its original shape. Okay, regain back its original shape. Is this clear? Right. Now, let us suppose if two bodies, let's say this is body A moving with some velocity of u1 and this is a body B moving with velocity of u2. U means initial velocity before collision. This is before collision. Before collision, right? And at the time of collision, both bodies will be moving with some same velocity. This is at the time of collision. Time of collision. And after collision, both bodies will be moving separately with some velocity v1 and v2. This is after collision. After collision, right? Okay, so there are two basic approaches of collision. One is a direct collision, second is indirect collision. What is direct collision? Whenever two bodies are colliding such that the line of impact is always parallel to the line of action of the velocity, or we can say this line of impact is always in the direction of velocity, then we can say this kind of velocities we call it as a direct impact or direct collision. When we are having a condition like this, let's say this is u1 and this is your u2. In this case, let's say this is the line of impact. This is your line of impact. In this case, line of impact or line of collision is not coinciding with the line of action of the velocity. This kind of collision we call it as indirect collision. Okay, in your syllabus indirect collision is not at all there, but I'll be telling you what's the difference. This is very easy, but slightly lengthy calculation, that's the reason it is not there. Direct collision is there in your syllabus. 40 minutes. 40. Okay. Right. But in direct collision, the line of impact will be in the same line as the line of action of the velocity that is there in your syllabus. Okay. So now please do let me know, if I want A and B to be colliding, tell me between u1 and u2 which will be having a larger magnitude. If I want body A and body B need to have a collision or impact, definitely we can say u1 must be greater than that of u2. Then only the collision will be taking place. If u2 is more and u1 is less, then body B will be proceeding forward and u1 will not be catching up, or body A won't be catching up. So the change in the initial velocity between u1 and u2 we call it as velocity of approach, because two bodies are approaching each other. After collision, definitely if they want to move separately, then v2 must be more than that of v1. Then we can say v2 minus v1 will be considered as velocity of separation. Velocity of separation, right? Why this is important? Because we'll be seeing one Newton's law of collision where we'll be using these two entities. Now, in the collision of the elastic bodies, the conservation of linear momentum, there is always be linear momentum will be conserved, right? So we can say that law of conservation of linear momentum is the total momentum of the system before collision is exactly equal to the total momentum of the system after the collision. Like in this case, yellow ball is coming with some velocity, it is transferring its momentum to the pink ball, and its momentum has increased. Like if I say momentum of body 1 is more, now after collision momentum of body 2 is higher. Okay, so now if I try to apply the system, we can say m1 u1 plus m2 u2, it is before collision, m1 plus m2 into, it is at the time of collision, equal to m1 v1 plus m2 v2, it is after collision. Let me draw it over here. This is u1 u2, it's at the time of collision, and this is after collision, v1 v2, right? And this will be always will be applicable. Okay, the conservation of momentum will always be applicable. Now let us suppose if we are having an inelastic collision, and in this case energy is also being conserved. The total energy initially will be equal to total energy afterwards, because there is no loss of energies, because it's a perfectly elastic collision. In perfectly elastic collision, let me write a star note. In perfectly elastic collision, the momentum, linear momentum is being conserved. Linear momentum is conserved. Along with that, energy is also being conserved. Energy conservation. Energy is conserved. That means you can apply the energy conservation here. Okay. But if you are having a inelastic collision, in that case only linear momentum is conserved. Linear momentum is conserved. Why? Because when you are talking about inelastic collision, there will be some amount of deformation left out. So some amount of energy is being lost due to the deformation. You're not able to regain back that energy. That is the reason in inelastic collision or in non-elastic collision, you can never apply energy conservation. But in perfectly elastic collision, you can apply energy conservation also and linear momentum conservation. Is this clear? Okay, fine. Perfect. Now, let us try to understand one very important terminology, that is your Newton's law of momentum. What is Newton's law of momentum? It states that the velocity of separation is directly proportional to the velocity of approach. Or we can say V2 minus V1 is directly proportional to U1 minus U2. Now, if I try to remove this proportionality sign, I can say V2 minus V1 is equal to U1 minus U2. This ratio will always be constant. What do we call this ratio? Anyone? What do we call this ratio? This ratio is denoted as small e, and that small e is a very important coefficient in the collision topic. This is, we call it as coefficient of restitution. Coefficient of restitution. Perfect, Ajay. Very good. Okay. And what is the significance of using this E? It is being observed that if you are using E equal to 1, okay, if you are using E equal to 1, if you are getting E equal to 1, then we are using for perfectly elastic collision, okay, or perfectly elastic bodies. If you are using E equal to 0, then we are going for perfectly plastic bodies, collision between perfectly plastic bodies. And between 0 to 1, we are having the collision of real bodies. Okay, fine. Now, let us take one statement and you will be able to understand very easily. Let us suppose we are having two identical bodies. two identical bodies. Identical bodies means we are having same mass. Same mass is undergoing perfectly elastic collision. If two identical bodies is undergoing perfectly elastic collision, then what will happen? Their velocities exchange. What is the meaning of this? If two identical bodies, let me write if two identical bodies having same mass is undergoing perfectly elastic collision, their velocities actually exchanges. Okay, right? Now let us try to prove it. What is being written over here? Now they are saying that perfectly elastic collision means E is equal to 1. We know that E is equal to V2 minus V1 divided by U1 minus U2, that is equal to 1, or V2 minus V1 is equal to U1 minus U2. Okay, fine. Now we know that same mass means m into u1 plus u2 is equal to m into v1 plus v2. This is from the your conservation of linear momentum. M u1 plus m u2 is equal to m v1 plus m v2, right? Okay, m get cancelled out, so we can say u1 plus u2 is equal to v1 plus v2. Now if you try to solve equation 1 and 2, we are getting u1 is equal to v2 and u2 is equal to v1. What's the meaning of this? That means with what velocity the body number 1 was moving, the same velocity will be there after collision with the body number 2. That means their velocities has exchanged. That means if I say there's a mass moving with velocity u1 and mass velocity moving with some velocity u2, after collision, this is A, this is B. After collision, what will happen? This is A, will be moving with velocity v1 and B will be moving with velocity v2, right? Okay, that means their velocity will be exchanging their magnitude. That is because as if two identical bodies is undergoing perfectly elastic collision, their velocities always exchange with each other. Okay, clear? Hai? Fine. Is this clear? Now there is one more case that we have to understand. That you can use directly in the examination. Let us suppose we are having a rigid surface, right? And a stone or any body is dropped from height h and it is undergoing perfectly elastic collision. It's undergoing, or not perfectly elastic, it will be very easy to understand. It is undergoing collisions, right? So you have to tell me after n bounds, what is the height? After n bounds, what will be the height of the body? Anyone? In terms of E, you have to tell me. Yes. After n bounds, what will be the height of the body which is released initially from height? This is released from here. Any idea? Yes. What will be the relation? It will be equal to Hn is equal to e to the power 2n capital H. You can easily calculate. Let us suppose when it is released from capital S, it will be hitting this rigid support with a velocity of root 2g capital H. Let's say this is the initial velocity. After collision, it will be having some velocity, let's say v1, and let's say it is reached height h1. So can we say v1 will be equal to under root of 2g h1, right? Okay, clear? Now if I try to apply the conservation of linear momentum, so we can say m into u1 plus this rigid support is not having any velocity. Let's say capital M is the mass of the rigid support. This is u2. This is tending to 0. That is equal to m into v1 plus capital M into V2, it is still, rigid support is not at all moving. Now, because V1 and U1 are in opposite direction, we can say this is, we can take it as negative. So M get cancelled out. So U1 is root of 2GH is equal to V1 is root of 2GH1, right? Okay, fine. Or what we can do, this won't be completed. Let me do one thing. Let me take the coefficient of restitution. That will be best. Chalo. So what we are doing is E is equal to V2, that is 0, minus V1 is your under root of 2GH1 with a negative sign. Why negative sign? Because it is moving in the upward direction, opposite. So U1 is root 2GH minus 0. So here if you try to solve it, E is equal to H1 by capital H root of this, or H1 is equal to E square capital H. Okay, E square capital H. So after first bounce, your height of the body will be equal to E square capital H. If you calculate H2, it will be E to the power 4 capital H. Same way, right? Fine. So if you calculate Hn, it will be E to the power 2n into H. So this way you can remember this formulation directly, you can apply for any body. This is for any body, like we are not keeping the value of E. If this is perfectly elastic, then E will be equal to 1. Then after every bounce, it will be reaching the same height. Okay. If it is completely plastic, after the first release, it will be not, it won't be bouncing back. It will be having H1 equal to 0 because E equal to 0 for perfectly plastic. Okay. For real bodies, let us suppose E is equal to 0.8, you can place it and get the value very easily. Directly you can get. So we can use this relation directly in the examination. For any type of collision, that could be perfectly elastic, perfectly plastic, or your any real bodies or a real collision. Okay. Is this clear? Right. Now let's talk about the next one, that is Lagrange's equation. Lagrange is very easy, very small topic, but you should be knowing the concept. What is Lagrange's? Now till now what we have discussed is, till now we were discussing from the Newton's perspective, where we are calculating the forces, where we are calculating acceleration. But let us suppose if you want to define our equations from energy perspective, there we are using the Lagrange's. Okay, so what is this Lagrange's equation? What is this Lagrange's concept? So Lagrange's, it states that you have to have one Lagrange function. Let's say L is resembling you the Lagrange's function, right? Okay, and what is Lagrange function? That is equal to the difference of kinetic minus potential, T minus U. Okay, where T is nothing but the total kinetic energy of the system and U resemble total potential energy of the system. If you take the difference of these two, we'll be getting the Lagrange function. Once the Lagrange function is being calculated, then you have to use Lagrange equations of motion. Then we have to use Lagrange's equation of motion. What is Lagrange equation of motion? That is del L by del Q minus del by del T del L by del Q dot equal to 0. Just you have to place it over here and you will be getting the answer. We'll be taking some examples where Q and Q dot are the generalized coordinate system. Generalized coordinate system. Okay, that means Q will be resembling you about the displacement. Q dot is your velocity. In short, Q will be giving you, in short I can say Q is giving you the concept of X and Q dot is giving you the concept of X dot. X dot means we are talking about velocity. X dot means dx by dt. X double dot means your double differentiation of displacement with respect to time, that is nothing but acceleration. Okay, let us take one example. Let us suppose you are having one Lagrange function, that is half mv square minus mgx. Okay, your kinetic minus potential, right? L is kinetic minus potential. So what we'll be doing, you will be calculating now. Q is being resembled by X and Q dot will be resembled by V. So now we can say we know the what is the Lagrange equation, that is del L by del Q minus del by del T del L by del Q dot equal to 0. Or we can rewrite this in our equation, that is del by del X minus del by del T del L by del V is equal to 0. So let us try to differentiate this equation with respect to X. So del L by del X, so that is equal to minus mg, that's it, because this will be constant, है ना? Okay, now if I try to differentiate this del L by del V, that is equal to m into V, 2 and 2 get cancelled out, and differentiation of this with respect to time, del L by del V, differentiation of velocity with respect to time is nothing but acceleration, so this is m into a. Okay, m into dv by dt is a. Now placing all this in this equation, if you try to place all this in this equation, we will be getting minus mg minus m into a equal to 0, or we can say ma plus mg is equal to 0, right? Or a is equal to minus g. Okay, a is equal to minus g, that we are getting. Okay, fine. That means if you are having a body which is moving in the upward direction with some a, so we are getting a is equal to minus g, very easily we are getting, right? Let us take one more example so that we are able to identify how we can proceed. Let us suppose I am having a pendulum, okay, and it is moving to some height at this point. Let's say this is having length L, moved by the displacement of theta. So now I can say that here your displacement or q will be changed to theta, and your q dot will be nothing but theta dot, that is your omega, theta dot, or that is your omega. So I can say I will be taking one reference line. So can we say that this distance will be, what will be this distance? Let's say this is L dash. So this will be L dash will be equal to, this is L cos theta, L cos theta. L dash is equal to L cos theta. So what is the total kinetic energy of the body? Total kinetic energy is equal to half mv square, half mv square. So or I can say half into m into v is equal to nothing but L into theta dot whole square, or I can say this is half into m into L square theta dot square. This is the kinetic energy that we have calculated. Now what is the potential energy? Because I am taking reference from this side, so this is the height h. So potential energy is equal to mgh, right? So m into g, h is nothing but L minus L dash, L minus L dash, that is equal to mg L minus mg L cos theta, right? We got the kinetic energy, we got the potential energy. Now what we have to do is we have to calculate the Lagrange function. Okay, now how we can calculate? We can take this one later on. Now how we can calculate? So L is equal to kinetic energy minus potential energy, right? So kinetic energy is half m L square theta dot square minus potential energy is mg, take it as common, 1 minus cos theta. Okay, so we got this value of Lagrange function. Now we can use this Lagrange equation in our calculation. So we can say that it will be, let me add one slide over here, one second guys. Almost we are about to complete this one. 1 2 3 4 5. Okay, so now we have calculated what is the value of Lagrange function. L is equal to how much? L is equal to half m L square theta dot square minus mg L into 1 minus cos theta. Okay, so first of all let us calculate dl by del theta. What is del L by del theta? Okay, because this is nothing but del L by del Q. So if you try to differentiate this, you will be getting this simply equal to how much? Yes, that will be equal to minus minus plus cos theta will be equal to sin. So mgl sin theta. Yes, mgl sin theta, right? Okay, now let us calculate cos minus 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 one more minus. Why? Because we are having one minus sign. Differentiation of cos theta is minus sin theta, right? So now del L by del Q dot is equal to del L by del theta dot, that is equal to half get cancelled, that is ml square theta dot, है ना, theta dot, right? Chalo, so del by del T into del L by del Q dot, if we try to differentiate, that is ml square theta double dot. Okay, so now let us place in the Lagrange equation del L by del Q minus del by del T del L by del Q dot in this is equal to 0. What is del L by del Q? That is equal to this one minus mgl sin theta minus this was equal to ml square theta double dot. Theta double dot equal to 0, or I can say this is ml square theta double dot plus mgl sin theta equal to 0, or theta double dot plus g by l. Let us suppose sin theta is tending to theta, theta equal to 0. Are we not having this equation for the equation of pendulum? Yes. If I try to compare this, we'll be able to calculate the natural frequency of vibration. Omega is equal to under root of g by L. Omega n is equal to under root of g by L. Yes. So basically, Lagrange also helping us to calculate our standard equation, right? Okay, you can calculate the time period of oscillation, that is 2 pi under root L upon g. Right? 2 pi under root L by g. That's it. You might have solved lot many questions in your class 12. If you cut the string, what will be the time period of oscillation? That kind of questions. Okay, so now let's take one problem of Lagrange's and you have to tell me what is the answer. Let's see who's going to give me the answer. They are giving you the Lagrange equation of, you have to calculate what is the Lagrange equation of motion for the Lagrange function given in the problem. So L is equal to half mx square plus half kx square. Tell me which of the following is giving you the correct answer. Which of the following is giving you the correct answer? Quickly. Okay. Here Q is being dissembled by x and Q dot is being dissembled by x dot, that means velocity. Okay. So we can say del L by del Q is equal to del L by del x, that is equal to x dot square, one dot should be there. Correct Ajay, because half mv square na, it is x dot square. So del by del x, it will be getting k into x, right? And del L by del Q dot is equal to del L by del x dot, that is equal to m into x dot, right? So now if I try to differentiate del by del T, del L by del Q dot, that is equal to mx double dot. Okay. So now if you try to place it over here, del L by del Q minus del by del T del L by del Q dot equal to 0. So del by del Q is equal to k into x minus this will be mx double dot equal to 0, or I can say mx double dot minus kx equal to 0. I think which option we are getting? Option D is the correct answer. Very good. Option D is the correct answer. Logic is same. Calculate the kinetic energy of the system, calculate the potential energy of the system. If you try to take the difference of this, we'll be getting the Lagrange function. Once you get the Lagrange function, then we have to apply the Lagrange function in this equation. And from there, you are able to calculate the final answer. Okay, fine. Understood? So this almost completed your mechanics in one go. Okay, almost I think we have done with this. Let me check. Yeah, fine, clear. Any doubt if you're having, please do connect with me. I'm again repeating, mechanics is a subject, it's not a lengthy one, it's a small subject, but you have to practice lot many questions, then only you will be getting one uh, basic understanding. And once you are done with the session, please try to attempt the quiz which will be unlocked at 5 o'clock. At 5 o'clock the quiz will be unlocked. You can scan this code, you can see on the screen. Yeah, on the back of my head, I hope you are able to see this code, है ना? Back of the head you are able to see, you can scan this and you can download the app if you are not yet downloaded, and from there you are able to attempt the quiz. Projectile motion is not that important. I won't be taking, the reason being projectile is already being eliminated from the syllabus in 2017 2017, right? Virtual work, yes, it requires some practice. I've not taken some questions also, right? Don't worry in the questions, because virtual work is quite easy. You just need to calculate the total work done and place it equal to 0. Okay, so for that you have to practice some questions. So I'll be taking questions from the topics which is being done, because that is more sort of a numerical oriented, right? Projectile not there in your syllabus also. If you want to study, you can study. It hardly take a minute. You have to go for that equation of trajectory, the range and the maximum height. I hope so that derivation is not even required also. You might be remembering that formulation. Projectile velocity, the angle of inclination, you can easily calculate. Okay, fine. So you can do attempt at 5 o'clock. Again repeating, at 5 p.m. you will be having the app quiz. In the application you'll be having the mechanics question. You do attempt. If you have any doubt in that now, you can do post your doubt on this Telegram channel. I'm again repeating, please post your doubts. Try to clarify your doubts at least 1 week or 2 weeks before the examination. If you're not doing this, then what will happen at the end? It will be complete chaos. And try to, because these are some small subject, easy subject, you can easily cover up in a one go. Okay, so that's it from my side. That, thank you for joining with me. Let's now meet in the mock test, where we'll be conducting lot many questions. Mock test will be there, and definitely you can do contact me directly on my Telegram channel. Okay, thank you guys. Bye bye, take care, stay safe, and try to revise the topics as much as you can, because revision is the only key to crack gate. Not solving 100 questions, if you're only solving 10 questions, that is also sufficient enough, but that 10 questions should be perfect. Okay, so thank you guys. Bye bye, take care, stay safe, and enjoy your preparations with BYJU'S exam prep. Thank you.